I need to be taken out and flogged. And I've never done that until our class last week. That was the first time I've lapsed on being able to get that started with us. So thanks for pointing that out. So, yep, we'll start our recording. How about that? We're just jumping back into our field to finish processing and talking about these additional draw options to control how to handle the arcs, whether to adjust the PC and PT vertices of the resulting polylines to bring the arcs into being tangent, giving it a specific limit on how much you're allowing it to move, those vertices, that sort of thing. Okay. So, and it's important to note when you turn this on, if you want to adjust the PC and PT points of any of the line work that has arcs in it, what you're adjusting is not the point, the surveyed point. That point stays as the value that it was computed as. We're not changing that point at all. We're just tweaking the vertex location in the resulting polyline. So if you were to get down and examine, look in close and examine that vertex where it sits compared to where the point is, there would be a slight mismatch because it's adjusted it to make the curve uh, tangent. So if you ever see that and get, concerned about that, don't or decide not to do this because you don't want to move the point value, then be assured that that's what's going on. All right. Now the point group that you saw me, I said to use right here in the additional. I said create point groups automatically by code, and there's another one that's also by code definition. And that is when we define the code, let's say we looked at shed yesterday, and we could have when we tell it we're working on points that have a description of shed. We have right now we will have let's say for that shed and building. Um, let's go to my edit codes and let's find that shed. So there's shed. I'm going to edit it. And down here where it says point groups, I'm going to call this structure. Structures. Okay. And so I'll do that and copy that. I'll say okay. And I'm going to go to the building code and do the same thing here. Okay. Say save and exit. Now I'll say okay, let it redraw. And now the groups that we've created, go back to my points menu, look at a point group manager. There you can see I've got a group called X. That's the description on those points. I've got a group called default that came from the code definition of UP, but I've also got shed. So those are the three shed points. I've got building. Those are the two building points. Let's see, I don't have my I didn't see my let's see. Oh, right here. I got to turn this on by code definition. All right, let that redraw again. And now I go back to my point group manager. And now you should see there's structures. So I've got building, those are the two building points. I've got shed, those are the three shed points, and I've got structures. And all five of those points are included in structures because in my code table, I define code shed and building both to add the point to a group called structures. Okay, so otherwise, these other groups that you see, Trav, X, Default, Hub, FL, EP, CM, BLD, those are all coming out of the actual code itself by the name of the code. Although this default, I don't have any codes called default really. There's a utility pole. So they may be, let's take a look at that code. So back to field to finish, edit my codes. Let's look at my utility poles. I don't see. Oh, okay. Yeah. So I don't have a code for utility poles. So that's why it dumped it into default. So, I mean, I've got a code called UP that I don't see in my list here. That's why I didn't get that as a code. But that's all those additional draw options and where you want to and how you want to assign into point groups. You know, that way then when you're going back and forth and then you're editing this, and now let's say we've been working on those buildings, 5, 6, and 7, and 18 and 19, you can come up here to your point range and just choose your point group and say, I want to redraw structures. Say okay to that, and then you'll see they'll go away and redraw themselves, but the others will stay intact. Okay. So again, an example of using point groups and how that can be helpful, perhaps. So let's get in, roll up our sleeves and get busy on these codes and see what they do. So back to draw field to finish, and let's edit our codes. Or I'm going to exit that and come back to edit the codes. Right beside it, there's a button called Report Codes. And that's also something potentially useful for large data sets and if you're switching. So you can report on your code definitions. And if you do that, you can say then only report codes that are in the current coordinate file. And if you look at that report, see if I can get this to be a little, so it puts little headings here. There's set control, ground features. These are the categories that are in their code list. So I've got hubs, concrete monuments under set control. I've got X under ground feature. That's my spot elevations. And you can see it's showing you what you have there and what points or, you know, which ones are used, which codes are used. I have nothing under utilities. I have nothing under trees. That's because I don't have any codes for those categories in my code list right now. They're in the coordinate file, but they're not in there. So if I look at that, let's report the codes and then let's uncheck this, only report those in the current drawing. Then you can see there's the entire code library as it exists right now. And if we look at it and then look at it from the other side, instead of the codes, let's look at the data points. This is the coordinate file. You can have it to sort by codes if you'd like, only report any undefined. Let's uncheck that one. And let's make our point range all. And say, okay. And now we say, all right, here are the codes in our coordinate file. Over here, where it says not defined, that tells you immediately, well, it's not in your coordinate file, but then you've got these other things that are, and this full name, that's the little description that's inside the code definition. And then this tells you the range of points that are making up the particular code. And then obviously, if you reported that with only report undefined point codes, there's a list of the codes that we need to define. Okay. So I'm going to actually grab a quick little screen grab of that, and I'll keep that up here on my other screen. So as we're going through, I can refer to it to make sure I finished it. Okay. So, so let's go back. So we're out of we see what the reporting can do. Again, here are the set buttons where you can line it, you can change it into a different code table library if you needed to. Because maybe you have one for one particular type of client work. And to erase existing, fish and erase in range. All right, so then if we edit the codes, now here's um, where we have controls and such to create the behavior of these codes. We can either add new codes to it, we can edit the ones that we have, and we also have some settings. If you look at these three columns of buttons at the bottom, you've got things that deal with the code table. You've got code table settings, and that's pretty globalized behavior control for your code table. You've got the ability to sort and substitute codes. You've got special codes, and that is a real powerful little usage when we're collecting our data in the field. We need to know about these codes and how to use them and what they do. We talked about the rectangle special code that finished off that 3 points of the shed building. It turned it into a 4-pointed structure. There's a slash button up here, a single forward slash. It means take everything after the slash and add that to whatever description we've got. We'll see how that works. So there's a few things here. There's one up here we didn't talk about yet. This called this jog code. We'll look at that in a minute on the house structure. So, but those are codes that the field collecting people are going to need to use to add on to these points to make this stuff work. Or when they come back into the office and bring this in separately, and we look at that and say, well, we didn't finish drawing the structure of the shed or what have you, then you can always sit down and edit the description of the points and add those codes in later as if they were added in the field. Okay, but the most efficient is, add them when you're out there. Okay, so in our editor box, we have a categories list on the left. And these are all done. You can add a category, subtract a category, edit the category, and reorder their, reorder the listing sequence here, the order. And they can be done there with individual categories, and then you can sit with a particular one or go back on the all and say over here, you can bring that into different categories. Now, those categories can also be defined when you edit a particular code. You've got a category assignment, basically, that you tell it, I want it to be a part of this category, and it's right up here at the top. Okay, and so these get created for you. So if I've made a new category out here, then this will show up in this list, and you can make it fit be assigned to a certain category. So you're going to see a lot of work in this unassigned, or maybe even all, and that's fine. That's just helps you organize it. So now these buttons down here, like I was talking about, these code tables, you've got the special codes, you've got GIS codes where you define GIS data that you're maybe creating. And now here's this button right here that says code table by point descriptions. Now, remember our list of, so you can, see there's our list of codes that we didn't have. I took a little screenshot of it. So those are codes that we need to work on creating. So we have a tool to sort of help us there, and this says code table by point descriptions. So if I don't have any codes, and I've got a coordinate file that I want to be using, I can just hit this, or even in this case, I'll go ahead and hit this, and it says, okay, so do you want to remove any appended digits? And that's to like SPT9 as an example. If that were the code, the description, we have appended digits. We talked about that yesterday. We're doing EPs, and then we started an EP running, and then before we get to the end of it, we started another EP feature, maybe a parallel line on the other side of the street, however, and so we called that EP1, then EP2, EP3. So we do want to remove any of these appended digits if that is the way we typically work with those extra suffixes, so that it doesn't create a code called EP1 and EP2. It only looks at EP. All right. And now it asks the critical question, do you want to append the current table or create a new one? So it's not going to replace what we've already got done. It's going to give us a chance to append it. So let's append it. And now we have added, and it should have come into unassigned, but it didn't. I don't know why they don't have that done. So now I'm looking at that 12P, I need 12P, 18D, 24D. So if I'll just sit in all, and I'll hit the little code title up here at the top. So it sorts alphabetically, and I see I've got 12P, 18D, 24D. I should see an 8P. There it is. And then I should, somewhere later, I'll see an IP and LP. And I see there's IP down at the bottom there. Let's see here now. There's LP, MH for manhole, and PL, PV, and UP. So it's added those to the list of codes that we already had. Now, the other thing is you could have had a code in here. Let's see.
Hey, Ken,
Yes,
my view doesn't show the category column.
this over here.
No, after code, where it says road.
Oh, right. Oh, I see. Okay.
Yeah.
Yeah. So very excellent point. Thanks for bringing that up. If you're looking at this and you don't see this category column or some other thing, this button's down at the bottom in the middle, the second one to the right. Those are your column options. That's, if you click that, that lets you turn on and off which of these columns you want to see. Okay. And so you can see there's all kinds of uh, things that could help you. So that will actually determine which columns are visible in your spreadsheet. Yeah, thanks for pointing that out. That's I forgot about doing that. It's almost second nature to either right click the list of titles in the columns or look for some ways to set those options, but that's where that is. So if you don't ever really need to worry about the categories, then you would not show those on there. And so now let's see what we've got. We've got here these 12P and all these things. Oh, it looks like what happened is right here. I have a category called trees, in which I had an oak code in my structure. But look where all of my new points got dumped into the category called trees, because that was my last category. They should have been dumped into unassigned. I think that's just a coding error that, we need to let Carlson tech support know about, and they can maybe work on that for the next release. So that's what actually comes about it. It dumps it into this category. So we can do a couple of things. We can say, well, all right, I know my 12P, that's a 12-inch pine. There's an 18D, which means 18-inch diameter, or 24-inch diameter. So those three codes right there, and there's also an oak. Whoops, let's see, let's get these three. Then I'll control click on oak and pine and tree, which I think that one's already in trees, so that one's fine. So these are the ones here that I've highlighted that are actual trees, so I can leave them in my trees category, just happen to work out. There's also an 8P, but now here's an IP, that's an iron pin. Now that should go in set control. So I would put that in set control. I also have, let's see, light pole manhole, property line, pavement, and utility pole. Okay, so I've got an IP. So I'm going to select, I'm just going to highlight that and choose move category, and I'm going to move that into set control. So off it goes. It's now been added. There's my IP. And let's go back to these last ones and get the rest of these cleaned out of here. So, oh, there's also an LP. I should have done that one as well. At the time, I didn't see it. Oh, and also manhole. Good heavens. I don't have a separate category for, yeah, so utilities. So I'll move that manhole into utilities. So now I should see, uh, what were the two? I think I put the two in the wrong category. Oh no, I had set control. There's my IP. There's my concrete monument is there. I did. Oh, there's LP. Yeah, that's the one I moved to the wrong, oops, to the wrong category. That should go to utilities. So iron pin, there's hub, iron pin set, monument set, a PK nail set, although they're not in their coordinate file, but that's in their code table. All right, so back to trees. Let's finish that up. I've got all the way down through oak, pine. Those are all trees. There's a property line that's going to be, um, let's just move it to unassigned if this case. For that, I've got PV, which is a point that has it's a point along a pavement feature. And I'll move that one into my road features. And then finally, there's a UP, which is a utility pole. I can move that into utilities as well. Okay. Thank you very much. All right. Thank you. My morning cup of tea has arrived. That's going to be lovely. Thank you, Diane. All right. So we've now taken care of assigning those. You can now restrict that to what you're working on. So let's go back to our structures category. And let's look at what we've got here. We got these buttons down below where you can select a category above or a code above, hit the edit button, or you can just hit the edit button that's to the left and that jumps you right into the edit. But there's something else about these buttons that you can do. If you select, uh, let's select all four of these codes up here. I've got building, concrete pads, um, houses and sheds. Now, these buttons in the bottom section, if you look at that, you could say, if you now have these selected and choose edit, you can now edit. It's just like being in the drawing and you select multiple types of things in the properties box. You'll see all the things that are common to those particular codes. So this is not the same thing as if sitting on a single code definition and hitting edit. That puts you into that really deep one. But at this case, you can do this and then you'll globally assign all of these behaviors. Let's say you had these, you wanted to change the symbol that was used for all the points to not necessarily to the type. You would leave that one unchecked, but you might go over here to the symbol size. And if you choose that, you would give that a specific size. So it makes them all consistently the same size. All right. And then, or if they were all going to be, non-surface or non-elevation. So this, or category, you could select, we could have selected all of those different points that we knew were utilities the first time. Instead of doing that there, we could have then said, all right, well, let's change that, um, to a different category type thing. Let's see, where was, yeah, there it is. There's category. So that lets you do that same type of thing. So with multiple codes selected, these edit buttons down here will bring up this common feature editor. Otherwise, with a single, let's go back to our shed and hit edit, and you see that puts us into the full on detailed code edit. Okay. So what we have then is where we were looking at that yesterday. Let's review this a bit. We've got these three tabs at the top. You got the general tab, things that control the symbol, things that control the line type. And we down here said we wanted to hatch those closed areas, and that rectangle command closed that shed, and that's what created that hatching. All right, so I'm going to uncheck that just to, don't need to, you know, hatch my buildings. You'll be able to see them. And again, a lot of times on our definitions, because in our general tab, we're going to assign a layer name for um, for these things to draw on. So when I do that, when I put this on a particular layer, then I'm going to consider the line work that gets drawn on there can be one of two things. It can have the color and the line style and the line weight that is, defined as being quote, or not quote, but it's defined as being by layer. Okay, but that is the name of a color. It's the name of a line style. It's the name of a line weight, and it's called by layer, means to go and look up the layer definition and use that for this feature. You can override those with specific colors, line weights, and line styles, in which case that's where you can also set over here where you've got this color button. You could set and choose a specific one or the predefined as by layer. So most of these are going to be done as by layer because we really are going to have, our layer definitions are going to probably be sophisticated enough to handle that. We'll make the layer assignments based on, or the line style assignments based on the layers. So that's where it's typically going to be. Now this 3D is on a layer called break line, which I made a specific color, but I can also, make that by layer. And then I need to go back. I'll go ahead out of here for a minute. I'll save and cancel. I'll come back over here, and for my break line, there you see I made that layer have a color 40, so that would now match up. So I go back to my field to finish, edit my codes, and I was in structures looking at shed. We were editing that shed. So now you see I've just changed that color to be by layer. So these can all be separate ones. And any of these things that you assign that do not exist yet, when this thing runs, it will create them for you. Now, you may need to go back and redefine, like this break line layer. When I first did that, it was probably just a white color instead of that golden color that I've got there, 40. So you could then go back and redefine it. And what I'm getting toward is on my line type of a particular code, So I have this layer called structures, and I've got the line type defined as just a continuous line. But for sheds, you might actually want to set a particular line type, and these are all the defined. You see the ones that say CAD in parentheses, those are all defined in our drawing based on the AutoCAD line type that has been loaded. Then you have these other categories called, they have entity after the name, and those are the ones that Carlson builds on the fly. You can see a preview of it, like the electric line, it shows a line, a gap, the letter E, a gap, and a line. Uh, Telephone, same thing with T's instead. And you then can use those and you would set these spacing scalars. That's how many plotted inches that you want the pattern to repeat. And the symbol size scalar, again, plotted inches of the size of the symbol that you see in the preview there. And so it will create a line style for you if you use that particular type of line style. So you got the ones that say CAD, you got the ones that say entity, and then there's these here that say continuous. And these are the ones, I'm not sure exactly the difference there. Oh, here's like this fence. See this fence E and fence 2E and fence 3E. Those are still entities. That's what the E means. If I were to say that, you see it jumps back to uh anyway, the CAD, the entity, and the continuous. You're going to see if I'm looking at a given one here. Where it says CAD, you see nothing at the end of the name over here in the preview side. If you see entity here, you're going to see an E. There's starting down here, you see that underscore E. So that tells you that's an entity type. And then if you get into these continuous, it has an underscore C. So again, these are ones that Carlson is going to build on the fly for you, created. I'm not, again, entirely sure the continuous, I think, if I recall, the ones that say entity are the ones like our fence line where it makes these as individual entities. The symbols are separate from the line styles itself. So right now, let's just test this out. We're working on shed. So if we said, well, I'm going to go back to shed and I'm going to set my line type to just be by layer for my shed code. Let's get a longer line and take a look at that. And that was their fence line. We might as well work on that one too. So I've taken the little hatch out of shed. And let's look at our fences and walls category. And there's our FL fence line. And let's look at its line type. So I hit my edit, I go to line type, and there it is, fence 2 underscore E. So it's the E line styles that, again, remember the E stands for entity, and that makes those into separate entities. I think the continuous as that underscore C, the third type of line style, is where they build the line style for you, but they make it a continuous line. So if you move the line, everything goes with it. And so I don't know why anybody really wants to use these E individual pieces. It's as if you've exploded the lines. But in any case, let's go to our line type and let's choose set the line type. And right now you can see it was set to fence 2 E. And if I'm just going to go over here and there's my E's. There's my electric E. Up here's my fence 2E. So that's what you saw was that continuous line underneath it and the letter X laid over top of it. if you were to do those individual, you can see the difference for the fences. Now, I would do what I would, recommend for fence lines then is to not use one that has an E category or has an E designation and just keep popping through and see if maybe there's one. I'm hitting the next button and I'm looking for, up there's a fence SC, FLC. That's probably, well, it probably does an FL symbol, like flow line. Here's one that's got, looks like a barbed wire fence, but the uh, with alternating barbs. Let me go back to previous. Here we go. Fence BC. I think that might be a barbed wire fence. We'll take a look at it. So if we choose that and choose OK, save, exit. OK, now let's see what our fence line does. Well, there's our fence line, and it's got, if I select it, I look over here in my line type and I see, there's a specific line type that Carlson just built on the fly. And it's supposed to be a fence line with X's in it with certain uh, sizes and spacing. Now, we're not seeing it. And the reason is our line type scaling is probably set incorrectly. So I'm going to do a little check here. I'm going to select this line type and I'm going to just make a copy of it. And I'm going to drag it out here. And I'm going to now make this relatively much longer. See, there you go. You see how the symbol shows up? Uh-huh. And it's way too huge for in relation to my drawing. Well, that has to do with line type, your line type scale. Okay. And that's something that we have to deal with this with Carlson all the time because Carlson treated in the early days the AutoCAD line type scaling in a different manner than we're used to using it now with standard AutoCAD practice. The way Carlson did it is when you go to settings, drawing setup, and you created your horizontal scale, it set your line type scale to be the same as that scale. But that relied on another variable called MSLT scale, which means whether or not you want the line type scale in your model space, which is where we are now. We're not in one of the layout tabs in the paper space. We're in the model space. If you want the model space to react to that line scaling, then you need um, to turn to have this one turned on, and it is on with the 1. So if I make that a 0, and then I'm going to regenerate all, REA. Now you can see there's my line type. There it is. It's scaled more appropriately for my work. Now, here's what I don't do, or what and you could use it like that and leave it like that. And so the way I do it, though, let me say, and the way you can choose to do it if you want, is you can leave your MSLT scale turned off. And then every time you change the scale of the drawing, so that's a 20 scale, let's make it a 10 scale. This number is going to change now. See, it changed to 10. I'll say okay. And now the scaling on the line style changed with it. Okay. So, but what I like to do is instead of changing this and have this change, and I'm relying on MSLT scale being off, is I like to, let me put this back to 20, and I'm going to make this LT scale 1. I'm going to always want that to be universally 1. Now, if I do a regen there, you can see how much tinier that is and how it's not very scaled appropriately. but I want MS LT scale, model space LT scale. I want that to be on as well. I have to do a regen to get that back. Okay. Now, the reason I do mine that way and keep my global line type scaling set to 1 is because I have other line styles that are built in AutoCAD line styles, not these created on the fly line styles that I would, I need them to react to and stay a constant size. So if I were to um, plot this, say, a 20 scale, I want the dashes, if it was a center line of a highway, I want the dashes to be every 2 or every inch and a half of my line style in my center line style. But if I made it from a 20 scale, then I plotted it as a 50 scale, I don't want the dashes to get, you know, proportionately closer together or further apart. I want them to always be consistent. So I want LT scale to stay as 1, but I need MS LT scale to also be on so that I can see those uh, the effects of the line type scaling. All right. So it's a little bit more sort of behind the curtain work in there, but that's how that works. Um, so if you don't see the scales, I usually just take a copy out and stretch it out to see if it's a matter of scaling, or maybe select something and then look in the properties, and you would see it had a line type scale that was set to 20 the last time, but now it's back to 1. Um, so that's often something we need to check on. All right, so if I'm looking at this, first of all, it's an ugly fence line. There's too many X's too close together, and the symbols are too high, in my opinion. So if I were to go back to field to finish, and let's look at that, edit codes, and we'll find that fences and walls, there's our fence line. We'll edit that, and we'll go to the line type. Now, again, I could have set this to be by layer instead of this, and then defined the layer as a fence line. That would be my actual first preference. But if I haven't got a particular line type yet, and I go to this line type and choose set line type, there's a couple places that are going to control something here. Right here, I've got a line type spacing scalar, and that means right now it's set to 1 to be a 1 inch. So I'm actually going to make that an inch and a half to spread them out a little further. And my line type text scalar, right now it says what? 0.25. I'm going to make that 0.08. So that would help to redefine this. But in addition to that, when we say set line type, and we choose that, and that was the fence B underscore C. So that would be, come down here and find my fence B underscore C, which is right there. And then you'll see the picture of it over here, fence, the last one in the list there. So what's that, fence C? Okay, so fence B underscore C. And then I've got these spacing scalars and symbol size scalars right here. So I'm going to make sure those are going to be what I want. So I'm going to space it out. Instead of every inch, I'm going to go every inch and a half. And I'm going to make my spacing much smaller. So my symbol size scalar. And in custom text, right now, this is built with a text called with a letter X. You might want to put BWF instead of X, so it stands for barbed wire fence, or you might want to, put FO for a fiber optic line, whatever it is. So this is really building a line style for you once you execute it. So I'll say okay to that, say okay to that, save and exit, and say okay. And now it's going to be a different looking fence line. And there you can see the results of it. So it made the lettering smaller, and it spaced the placement of these out further. Okay. And now, when you look at that feature, it has a specific fence line called X1-05 underscore 0-0.1 blah, blah, blah. And if you happen to check, let's look over here in our layers property, then I've got a fence layer. And right now it is assigned as a continuous line style because that line was defined specifically. So if I look at this one, I can now choose, you see the two ones that, these are the two line styles that we used so far that Carlson actually generated and created as a part of an AutoCAD line style. And you could also, though, go to load and you could find a particular, let's say maybe you've already got a fence line in your line style library. There's a couple of them. There's fence 1 and 2, but they use circles and squares, so I wouldn't need that. Maybe you've got gas lines and things like that. I think what I will do here, though, is I'm going to add up a bunch of these line styles just in case I need them for something later on. There they are loaded. I'll say okay. It's now continuous. Let's load also from I'm going to switch to in this other file. And this time I'm going to come down here after all of those numbered styles. I don't necessarily want them. And let's start from this one. This is 2 dashes. And we'll go all the way down here to the bottom. Say okay. Yes, we're going to reload all. Okay, and now let's finally go back and look and see if we've managed to pick up another fence. I think the only fence lines we had in there were the 1s and 2s. There it is. So they would be the different symbols. That's one with the circle. There's one with an X. So that didn't really give me my typical fence line. So I'll stick with what Carlson gave me. But if I look at those ones that Carlson gave me, what was the name of that? That was called X. It's down here called X something or other, and it doesn't say fence. So back to my layer assignments, fence. I could make this, and I'll scroll this down there and find that down in these X categories. There it is. There's the first one. There's the second one. I'll say okay. And now that the layer has been defined, my code for this line, instead of being specifically that line type, it could be simply by layer. All right. So just however you want to manage this, like I said, most of what we're going to do is going to be based on layer defined characteristics. And we can just set line styles, colors, whatever, to be by layer. Okay, so you can control it at the layer level. You don't have to go back and rerun field to finish. All right, so let's look now at some of the rest of it. We fixed the fence. So we'll go back to our draw field to finish, edit codes, and let's work on those that we needed to redefine. We've got 12P, 18D, 24D, 8P, IP, LP, MH, PL, PV, UP. All right, so we've got LP and UP. One's a light pole, one's a utility pole. And the light pole, let's see, let's go to utilities here. Now there's a PP, that's a power pole, but I don't think I've got that in my coordinate file. I think that's just, it was in the table earlier. So if I have a light pole, I see it's already under categories, but there's nothing else to it. So I'm going to choose light pole and edit it. And so here we are. There's the code. And the full name, again, I might type that out just for my reference later. The description is going to say LP. Now that means it's going to put that description in the drawing next to the point if you want it to be on. Well, for a light pole, I'm going to let the symbol do the talking, so I'm not going to put anything in that description. That does not take the description away from the point in the coordinate file. That's just what goes in the drawing, okay? And the main layer that I want that to go on right now, it just assumes it's going to go by the same layer as the code. But I want to put these utilities on like a, it's a separate layer. So instead of UP as a layer, I'm going to set that and look and see if I've got a utilities layer in there. I do not. All right, so I could give it a layer name. Now I could type that as utilities, but utilities is a little too broad because I'm going to have sewers. I'm going to call this UTIL for utilities. And actually, let's be a little more true to National CAD standards. So V-util dash, I'm going to call it telecom. So it's be telecommunications, data, power, TV, that sort of stuff, instead of like sanitary sewer and storm sewer. So I may want those as separates, which I will. So let's see, let's call that telecom. So I'll put light poles, utility poles, power poles. I'm going to put all of them on that particular main layer. All right, so I've done that there. Now that layer will be created next time I go to run the file. Now the distinct point layer, if I do that, I can assign, there you see I've got, it uses the same name and then it appends, it makes a second layer and tells me that's where the point it goes. Otherwise, the point itself will stick with the same main layer. And I have no particular need to freeze off the points, but keep any line work for these particular codes. So I don't need to do that as a distinct point layer. So I'm going to leave that one unchecked here. And in this case, because I'm drawing power lines, or in this case, a light pole is not actually going to have any line work coming up to it. It's going to be treated as a standalone, like an area light or a yard light kind of light. So I'm going to just not make any 3D lines associated with it, nor even any 2D lines. I'm just going to come there at the bottom and say point only. I'm going to come up here, set my point ID to the way I like it. Separate attribute layers. No, I'm going to leave those just as they come in as a point. There's a point group. If I wanted that to go into, right now it's in a group called LP. You might add that to a group called telecom. So it sorts the points into those groups as well. And at this point, my attribute size scaler. So this is the size of the symbol, or I'm sorry, the attributes. I'm going to match that back down to my normal preference of 800ths. And then my elevations, everything's good. Located on the real Z, that's good. It's a feature type, it's topo. That's all good. And I'm going to go now to my symbol. Right now, that's going to be that default point symbol. So I'm going to choose that, and I'm going to come down here until I find a light pole. And see, there's my more electric type pole. You could use that SPT44, or there's what I'm looking for, SPT48. So that's going to be, and I can put that in the legend and say that represents the light pole. Here's a name. Okay, you can rotate it to any line so that if you've got a symbol like a curb inlet, that is squared off and you want it to line it up with an edge of pavement, you can tell it to rotate to the line. It won't make any difference for us. We don't have a line. So that's all I want to do with that. And then line type, of course, just leave it as by layer, but there is no line type because over on general, I said points only. All right, so that took care of LP. Now UP, that's a utility pole. And I'm going to control click under PP. So I've got power pole and utility pole. And if I choose edit for that, I want to set that point group. Let's see if I get that as a choice. Yeah, it looks not. So no need to worry about those. But all right, so we have our light pole. Now let's do the utility pole. Now this is going to be the one like the power pole that's going to, this is just the crews went out in the field and they came back and called it UP for utility pole. So I'm going to say utility pole is my full description. My description to goes in the drawing again, I'm going to blank out. I'm going to make this main layer. Again, as I'm going to put this on v-util-telcom, which you could pick from the set button if you've run it once before and managed to have that created for you. Right now, it doesn't exist yet because I haven't run the first time. And instead of points only, I'm going to say a 2D polyline because I'm going to connect all of these with an electric line symbol to bring in my power lines. So I'm going to say a 2D polyline instead of 3D because the elevation of these points are, probably, they're taking them at the ground right next to the pole, perhaps, or maybe, they're using a robotic total station and it's, part way up the pole. So it's not really applicable to the line that draws between the poles. So it won't help me to have a 3D line as a break line. So I'll go to my symbol, and this time instead of that light pole, I'm going to look for one that's a little more electric pole looking like this one right here. Or it could have been this one here if I chose that SP. Let's use that one. It's got the line going through it. And over here as an option that says rotate to line, let's turn that either the line coming from behind, that's the backward, or line headed forward. Let's use the one that goes forward. Okay, and then rotate entities, the symbol. Just going to rotate the symbol, leave the point attributes unrotated. So we'll rotate the symbol to make it rotate into the line direction, and that'll take care of that. And we'll go to the line type, and this time we'll set the line type, and we're going to look for an electric, but I want to make sure I use one of these continuous, or if I had an electric based on the CAD definitions, I could use that as well. I don't know that I do. Nope, D to H. So I'm going to scroll down here and look under the continuous and see if I see an electric. And there's an electric 1 and 2. So my electric 1, if I click that, it's going to show me the picture of it. I choose which one I want. I see down here I've got electric 1, electric 2. So electric 1 has these little weird symbols. I'm going to choose electric 2. So now, though, I'm going to make sure this spacing scalar and symbol size are the way I want them to be. So I'm going to put that again at a 1.5 every inch and a half. And the symbol size, I'll make it 0.1. And I'll make sure out here I've got the same thing. Line type spacing is 1.5 and the symbol is 0.1. All right, so that's not going to be my electric line. I've got, there's manholes. So let's choose that manhole and edit it. Now again, I can put these under specific uh, groupings and layers, etc. Put it under the point groups. You might make called sewer. Now you've also got a group called MH already being made. Um, but again, just going to help you organize your points. So if I edit my manhole, really I'm going to keep it as points only. And you might put for the description, instead of say MH, maybe you would put SAN for sanitary manhole. Okay. If you know what it happens to be. It wouldn't be, if you're going to use a code called MH, you wouldn't put sanitary here on it. You would typically either have like 3 separate manhole codes. You might have a sand manhole, a storm manhole, an electric manhole, something like that. Or you could just leave it as manhole. But in this case, these are just sanitary sewers. So we'll change this description in the drawing. No, the main layer. I'm going to again put this on V dash SAN. So it's going to go on a sanitary sewer layer. And points only at this stage, because we don't really necessarily know that the 3 manholes that we found, we don't know that they connect, but they might. We could add to that later if we determine that. So we could at this point say that, and points only. So we go to our symbol. Let's choose a manhole symbol. I'm going to pull this down and choose inlets and manholes, and let's find an appropriate manhole. There's one there with an MH. There's one here with an S. So let's choose the S. Looks like sanitary manholes. Make sure our symbol size scalar is good to good to good. Looks good. And say OK. I think that's all we need for that one. And we're done with those utilities. Now let's look at our set control. And we had that iron pin, that IP, that's one that we brought in. You see there's nothing defined here, so I'm going to choose that. The description, there's an iron pin. Now you would obviously make a description as, you would make a distinction probably between an iron pin found and an iron pin set. So I would call this my iron pin found, because it's my field to finish. I'm bringing this in from points that are surveyed. And I'm going to put this on a layer that I want a layer here called, is there a control? There's a monument layer. Let's put this on that layer. And again, no line work, just points only. Set my attribute ID for that one too. And under point groups, I should have, what does that say? It says survey. We could do that, or let's create a point group. We'll call that monuments. And those are going to be IP. Let's set from a list, let it read the file. So I've got an IP. And I've got a concrete monument. If it's an MON or a C. There it is, CM. That's just IP, comma, star CM star, I think will work. Save that. Now monuments, no, it doesn't find the CM because of all that embedded list. All right, still though, it'll have we can make the other code force it into that one as well. So it's going to go on this layer called monuments. You could put it on, a layer called P-core, whatever you'd like. We set our symbol already. No, we did not. We are on what are we on here? IP. So an iron pin. So we'll set that symbol. Now, when we go back to our points where we would typically choose an iron pin. Now, when you do an iron pin set, here's the way a lot of folks will treat the difference between found and set is founds will be hollow and sets will be shaded in. You can see the difference between, say, 2 and 3 or 4 and 5, slightly bigger, would be basically found and set. So we're going to use, the set being the proposed and makes it heavier. That's the idea behind that. So these are going to be one of the open circles, but here's what I want to point out to you. It's a relatively new feature in the points, is that if you choose one of those round circles, that's fine, it will draw that, but you're going to see, let's say it's at the junction of two lines that come together, and that's right where the corner of the property might be, for instance. So it's going to draw that circle around that corner point, and you're going to be able to see those two lines where they intersect in the inside of that circle. Now, in the old school days, what we would do when we plotted things on using a pen on a drafting table is we took we took the little electric eraser and we kind of dabbed down into the corner. We drew a circle with their circle template, and then we scooched the edges of the line up to the edges of the circle. And so it looked like it was white, solid white in the inside of the circle, right? So instead of doing that, and then of course, when CAD systems came along, we would do that. We put the circles down, the lines were already connected point to point, and we would use the circle as a trim boundary, and we would trim the lines back to the edges of the circle. Well, now the lines no longer meet at their intersections and all of that. But for drafting purposes, that was all well and good. We really need to keep the lines at their intersecting points because we use those lines now for computational purposes more than just drafting purposes. So we have a new category up here at the top of points. We have points slash wipeouts or points plus wipeouts. So this will be a series of points that are created, and they have included in their symbol is a wipeout, which is just a drawn polygonal figure that sits behind the symbol, and it basically has a fill color defined as background. So whatever a background color is, whether it's on a black screen or a white piece of paper or whatever it happens to be, it's going to blank out anything else that's underneath it in the draw order. So sometimes, even if you use these points, you'll wind up making an edit to a line, to one of the property lines that comes in. And so it now has the most recent change. So it sits on top in the draw order. So you have to go back and change the draw order of your points to bring them up to the front so that they sit over top of the other parts of the drawing. But this is going to be, and I'll choose this SPT4 underbar or underscore W, which is the same circular symbol, but it has a wipeout behind it. Okay, so we'll take a look at it in just a minute. So sometimes when you do those, you use the wipeout coded points, you're going to, based on a setting of your CAD variables, you may or may not see the border of the wipeout. Sometimes, you have a thing called wipeout frame. That's the uh, that's the what do I call it? The variable, the system variable. It's called wipeout frame, and it can be one of three states. It can either be completely off, or it can be on and plottable. So if it is on displayed and you see it, it will also plot. Or they can be on but non-plottable. So it's 0, 1, or 2, in which case I like to just leave them off, but some people like to be reminded there's a wipeout somewhere, and so they'll leave the frames on but have them not plot. Your choice. All right, so we'll see that when we uh, take a closer examination of the results. All right, so there's our IP. We've done LP, UP, IP, manhole. I think that's good. I'm going to go back and double check something on manhole that I forgot to switch was my attribute layout ID, and that's just a preference. There's nothing that helps. Um, okay, so let's see, Kim, I see you looking back at my chat window. I'm sorry, I don't keep track of that chat window very, I don't keep very good real-time chat. Are you still having fence line issues? Did you ever get your fence lines to show up?
My fence line's back, yes.
Oh, good. All right. Well, one needs fences every now and then. I'm glad to see that it's good. All right.
Thank you.
Yeah. Okay, doke. So now, let's see, we've done the manholes, we've done the PL, we did not do. Now the PL, and then I think we moved to unassigned. That code in this particular file indicates a point on line. So it was a point that was set on the actual property line. So it could have Uh, you could give it a particular symbol if you wanted or whatever, but really it's just a point that's going to be on the line. So I'm going to not really bother with any kind of coding for that one. Okay. Now the PVs we haven't done yet, and we moved those into the road features, this PV, and that stands for pavement. So here I've got one called Mark, which is a road pavement marking. I've got a PV and I've got an EP. EP was already in my list, but and I do have some EPs, edge of pavement, and I've got PV, which is PV, just stood for pavement point, and that's around the driveway down at the bottom. I normally would have called that, EOD or something like edge of drive, whatever, but you get the idea. So let's look first at our EP code. So I'm going to select that edge of pavement. Now this was already defined. We may want to verify it. So we're going to choose edit. And I see a code of EP, my full name. I really should edge maybe PDM, so you can abbreviate that, but I want to sort of spell that out. I'm not going to put anything in the drawing, so I'll leave that description alone. And it's going to go on a main layer, and this is going to be a V dash road dash, I forget what the standard is, edge, and then either like, that's the edge two months, or maybe some ASPH. So let's see, that, or you could just put, you know, E EO, what, we'll leave this as the V road edge. Set the color. Now it's set to a specific color. You could set it to be by layer, which is what I typically like to do. And then I have to go back and redefine my layers, but be that as it may. All right, so that's going to be those points. And I want those points because it's the actual edge of the roadway. That's an actual hard edge in the field, so that needs to be a break line. So I'm going to make a 3D line for that for sure, but I'm going to also usually always make a 3D and 2D dual line. The reason for that is so that I can get a 2D line. So if it has arcs in it, which this one does, they stay as arcs that I can then uh, dimension, and it can pull out the radius of those arcs. And also with line styles, because when you make a particular line style, if it's an AutoCAD standard type of line style, they will only show up in 2D lines. Once you have a 3D line, polyline or anything, the line styles, they just drop out and become continuous. And it's because AutoCAD, for whatever reason, I don't know why, never had figured out how to represent patterned lines in 3D space. Now, that's why that original fence line, remember, was a line and a letter. That's one of the reasons why Carlson had done those line styles like that back in the early days, was because that's a way they could sort of trick AutoCAD into displaying something. So even if that was a 3D line, you would still see the symbols as part of that line style because they were made into they're made into individual objects. They weren't into a consolidated line style. So that again, in AutoCAD work, you don't have that same limitation with MicroStation. MicroStation displays patterned 3D lines with no problem. They just basically recompute the way the line should look in that whatever orientation you're looking at it, whether it's from plan view or you're in a perspective view or whatever, and it's always basically created normal to the viewing direction of the screen. All right, so that's another good reason to keep if any of these codes, if you're using to generate 3D lines, that's another great reason to also generate a, a companion 2D line to go with it so it carries the line style. Okay. And you can freeze the 3D lines after you've used them to create your surfaces and then go from there. So I'm going to make a dual 3D polyline layer. And again, I'm going to put that on my break line layer that I had already used. So that's where that's going to go. I'm going to get a 3D line. I'm also going to 2D line. The 2D line is going to go on this V rotated, blah, blah, blah. And I can say I want the points, if I want those points to be frozen, I'll put it on a distinct point layer, and it's going to use by suggestion, which I'll accept, the same layer name, but a suffix of P and TS, so I can freeze the points separately from the lines. I think we're good there. I'll double check under symbol. Right now, I'm going to get a little X symbol to show me where the point is, and that's fine. I'm going to leave it there, but I can freeze that layer separately. Remember, I just put it as a distinct points layer. And then the line type, of course, is going to be bi-layer, whatever that edge of pavement layer line type is going to be. Okay, so I'll say okay to that. Now that's the edge of pavement code that was already there. So let's go to the PV code. Now that's the pavement. That's my driveway code. So I'm going to edit it. I'm going to again go to description and take that out. And I'm going to come up here and just call this one pavement. I normally wouldn't do that in this particular case. It's an edge of, let's call it edge of a driveway. Edge of drive. If I just said pavement, that would be like a spot shot out in the middle of a paved, like a parking lot or something. But these are specifically along the edges. And I'm going to, again, make a dual 3D and 2D and make this dual 3D layer using break line. And I want the point layer separate. Now my main layer, there it is. I want to put that on V dash site dash drive. I think the standard coding for PinDOT is still V dash road dash drive. We'll call it that. V dash road dash drive. And then I'll make a distinct point layer so I can freeze them separately. Again, looking at the points, if you want to see the points or not, and then the standard line style. Okay. That was the last one. I said we'll come back to the trees later at this point. So I'm going to save and exit and hit the OK button. It's going to erase everything, recreate all that we've done so far. And so now let's take a look at it. We've got, you see the goldish looking lines. Those are our 3D lines. And in fact, if I zoom out a little bit here and just spin this up, you can see the things that are 3D versus the things that are 2D. And you see the roadway and the driveway have both 2D and 3D components, but the fence line and the electric line, you can see, do not have a 3D line. They're just 2D lines, same as the traverse lines, okay? So I'm going to put that back and go back to my top view. And by the way, how I'm doing that is holding the shift key down, and then while it's held down, I press and hold the wheel on the mouse and then move the wheel on the mouse. And that lets you do this here in their standard AutoCAD window. Now there's obviously another viewer. And if we looked at that, this is Carlson's 3D viewer, and you select everything. And when it pops in, right now it's set to ignore 0 elevations. And that's all you're looking at are the things that are defined by 3D. If I uncheck it, you'll see the other ones, but you see how they're not exactly over top of each other. And that's because you're looking at this stuff in a perspective projection. So there's your there's the projection of that stuff in our 3D. So let me take this off and go back and turn on to ignore 0 elevations, which is what I typically would be doing. So now that's just our 3D line work. So let's go see what else we need to fix. Well, let's zoom in and see some of the result of what we have happening. Here's our fence line. We changed that. Here's our iron pin found. Now, this is what I was going to tell you about. I wanted to show you about. You see this little hexagonal looking thing behind it? That's that wipeout frame. And you can see this line, even though it goes to the center of that circle, it's clipped at the edge of that wipeout. It looks like it's clipped because the wipeout sits on top of it. If I were to select the line, then right click the mouse and choose draw order and bring that to the front, now you can see the line. Okay, so if I then select the points, right click, draw order, and bring it to the front, it now sits over top of the end of that line, and that's the wipeout. But I'm also looking at that little hexagonal shaped border because AutoCAD also can't do wipeouts as circular objects for whatever reason. They have to be chorded. And so you're going to see a little bit of bleed over into those edges. But there's a variable, again, wipeout frame. You just type the word wipeout F, and then wipeout frame will come up. And right now it is sitting at a value of 1, which means it will be visible but not plotted, I think. It's either visible and plotted, visible, not plotted, or completely non-visible. So I'm going to make mine 0. So now I no longer see the frame, but You see where that line goes just a skosh past? That's because once it hits that edge of that wipeout, the wipeout cord is pulled back away from that circle edge a little bit. But you can see, at that scale, I don't care. It looks fine. Now look here. What do I have? I've got this point here, number 8 of 511.97 feet. And there's no description. I've got this point, let me escape that, and it has a 0.8 elevation and a description of IPF. So what's the difference here? Why do I have 2.8s? So if I double click that 0.8, that is, again, point number 8 with these coordinate values. And it has a CRD file description. So in the coordinate file, it has a description of IP space FL. So that means, that it's actually interpreting both the IP code and the FL code. And so keep that in mind, it's double coded. And I'm telling it to give it this drawing description of IPF, or iron pin found. Okay. So where did this little slightly smaller, different layout ID, it's got the point centered above the elevation to the side. Let me double click that one. And I see, well, that's still 0.8, and it still has this CRD file description of IP space FL, but there's no drawing description. Okay. Now, where that came from and why we see it is based on something very specific. And we're actually allowing 2.8s to be in the drawing. But if we go back to Survey, Draw Fields to Finish, and edit the codes, and right now, the point would be controlled by the IP code and also by the FL code, the fence line code. So it puts basically 2 points down because it had double codes. It says if you shot 2 points at that location. So there is a setting. Let's look at our code table settings now on the left-hand set of buttons. And right up here in the top right, there's this little pull-down setting that says use multiple codes. I said line work and points. And if I say line work only, or maybe even line work and symbols, if I said line work and symbols, then it's going to use the assigned symbol. I'll get the IPF symbol, as well as if I had a symbol for fence line, I would get both of those symbols. And if I were to use line work only, means that it reads the first code, the IP, uses its symbol, but then the FL, let's say the FL code, we told it to not only draw the fence line, but for fence posts, all these fence corners, we had a smaller circle. Okay. So if I said line work and symbols, I would also see that smaller circle inside my bigger property corner circle. But if I say line work and symbols, then instead of reading, see how it would do it. So if I said line work and symbols, then what it would do is take the line work for the first code, take both symbols. Yeah, I would use both symbols and the line work. But if I said line work only, then it would put the symbol for the first point, but it would not also put the second point's symbol down over top of the other location, but it would honor the line work. So in that particular case, it matters which one you actually save in the data collector first, because that point could have been set IP space FL. It could be FL space IP. So depending on what this switch is going to govern. So I'm going to say line work and symbols. I'll say okay. And all I've done is told the table how to behave, save it, exit. I'll say okay. Everything gets erased and recreated. And now when it comes in, you see you no longer see that double point, and there's only one point there because, and yet I get the symbol and I have the line work because this one is the same deal. There's the symbol of this concrete monument. So let's look at that code next. And I see nothing else underneath there. So back to field to finish, back to edit codes, and we're going to look at our there's a set control. There's our CM. It's under set control for concrete monument. I'm going to, I wouldn't call it set control, but that's where they put it anyway. So I'll say it's a CM concrete monument. The description, I might want to call that a CONC space MON in my drawing. Okay. This full name is just the listing information. And it's going to go on a layer. And again, I've got a layer called Mother's Monument. I think, did I put my iron pin on the same layer? I think so. You get the idea. B road. Okay, that looks good. So, and then I'm going to look at my symbol. And if I'm going to have I know that that code has a description of a diameter. So instead of a square, I'm going to use this particular one as a circle instead of a square. And I'm going to up its size just a little bit. So I'm going to call it 0.15 inches. So it'd be a little bigger. I think that, let me go back and double check. Let's look at my attribute ID. Number 2, set control category, point only. So that's good. I got the symbol. There's its layer, goes a monument. You could give it a separate distinct point layer. I don't think we have any need for that. We'll say okay. Okay, so if we look at that point, that CM point, I'm going to go over here in the right-hand set of buttons, and I'm going to choose Edit Points. I'm just going to take a look, and it's this very first one up here at the top. And that says it's an FL, that's the fence line, and it's also a CM, which is a concrete monument. But after the CM is a designation of a forward slash and then parentheses, 4-inch DIAM, close parentheses. And remember, that is our special code for saying anything after the slash. I want you to append the description of the drawing description itself. Okay. So now here's what's going to happen. I'll go ahead and close it off. I just wanted to look at that. So you're still going to see nothing happen to it. So if I go ahead and say okay and just have it redraw, it's going to come in and not see. Now there is, all right, there's 0.1. Well, why do I have that? Well, that's that round symbol, but I don't see any description. Okay, now that one should be bigger than that iron pin. In fact, let's check its scale. It is a scale of 0.15, so I may want to make that even bigger. And that's got a scale of I'd have to look at the but I have to break that out there and look at it. The scale, there it is, 0.1. All right, so I can make that a little bit bigger, but I don't have the description here. So let's go back to field to finish, and I'll show you why this is happening. Because keep in mind the order of the points. Remember I said how we treat that second point was symbol or line work and symbol only. So the second point, it got the symbol, but the point was turned off. So the point never gets processed. I never get to read that description of the point unless I put it first. So I could do that since that fence line is secondary to the concrete monument, I can recode that point and just flip-flop those descriptions, those areas. So back to field to finish. And if I edit my codes, again, I'm going to look at my code table settings, and right up here again, I said line work and symbols. So if I said line work and points, I'm going to draw double points in there, but I would get those point descriptions. Right now it's line work and symbols, so it's going to not process the point of that second one, but it would allow any symbols to come through. So what I need to do there, now I could switch that to say line work and points, but then I'd get double point drops, just like I did out here on the other end of the fence. So what I'm going to do then instead is, let's find that CM, which is under our set control category, CM, and we'll edit that feature. So the first thing is on the symbol, I'm going to make it bigger than the 0.15. I'm going to make it 0.25, so I'll make it a quarter inch. Be a huge symbol. And now what I need to do is edit my points. And I'm going to take that very first one up here. And if I look at point number 1, it starts with an FL. That's the first one, the fence line. And then the secondary code, which it said don't do the points, was a CM. That's the one I want as the points. And if I look down here at number 8, that's also an IP space FL. So in that case, the FL was secondary, and the IP, that's why you can read the IPF description, because it got processed first. So all I need to do here is come in here and edit this description of that first point from the CM slash parentheses 4-inch DIAM parentheses, go to the end of it and put space FL. So that's the way I should have coded it. So I'm going to now switch the coding. I saved the file. I'll exit that. I'll save and exit and OK. And now when it draws, oh boy, I really messed it up. That's why it got placed last, was because I had that slash 4-inch diameter, and it took everything after that as just extra documentation. So it ignored the FL. So that's why that got coded first. So you see how this works? If I look at this point, look at its description now. So CM, concrete monument, is set to, and then look at the drawing description above it. But it says CM, so do whatever CM says to do, and then there's a forward slash that says everything after that point is just appended to the description. So the FL got ignored as a code. All right, so that's why the fence line disappeared and why you don't see that. So what we need to do is put that back, and we need to change the way our secondary point behavior works in our edit codes, our code table settings. So instead of line work and symbols, I'm going to need line work and points, and then I'm just going to need to live with having dual points. And then I'll edit my points, and I'll fix this so that the FL space comes at the front. But that's why, because that slash is what killed the FL from being read. If that were not in there, if it just said CM space FL, it would come back and say ConcMon, and the FL would work, and everything would go along its merry way. All right, so we'll close that off, save that change, and now you may have noticed it went right ahead and recreated this at this stage to just show you the raw description. Now that's going to be what we'll do. I'm going to also make these manholes just a little bit bigger. So that was an MH code that's under my utilities. There's my MH. I'll edit that. I'll go to the symbol. I'm going to set a 0.1. I'm going to make that one a 0.2, just so they get a little bigger. All right, so now while we're here, before we go about and redo it and redo it and redo it, let's take care of our trees. I've got 12-inch pines, 18-inch diameter, 24-inch diameter, and 8-inch pines. So they did the trees two different ways. They've got some points that are coded as 8P and 12P, meaning to them as an 8-inch pine and a 12-inch pine. So they've got two separate codes defined as 8P, 12P. The other ones, 24D and 18D, are really, and they're also two codes, but then they have a slash, and then the name of the tree species. I think they're called oaks. So you got a 24D slash oak and an 18D slash oak. But 8P and 12P are both going to use pine, pine symbols. They're both meant for pine trees. So it's just two different ways of however you want to code up your trees. So I'm going to look at the pine trees first. I'm going to choose 8P. I'll edit that. And the description, I know that it automatically an 8-inch. So that's what goes in my drawing. I think I may have missed the right symbol. There it is, 8-inch drawing. And I'm going to put it on a layer called V-site dash or V-topo. What most people would use, V-topo trees. Points only, so no need to worry about any lines. I'll make those with that particular attributes. I don't need a separate point. Layer. No, I'll keep them on. So then let's look at our symbol. I'll choose that and choose my trees symbol. And we'll find one that looks more like a pine tree, like that one there. I think that's maybe 19. Anyway, or 27, some of those. Depending on what, you'll have some symbol you want to use. Represent a pine tree. Now, these are getting into some that are actual three-dimensional symbols, so, have fun. We'll play around with some of those. So we'll choose our conifers as, I'm going to choose that 27. And now for an 8-inch, I'm going to make that relatively small-ish. So I'm going to call that a 0.08. And that should be fine. I'll go to my 12P. I'll do that same category. Now this time for my description, that's a 12-inch pine. I'll do the same thing here as my full name, but the description for the drawing, 12-inch pine. The symbol was that same tree symbol, the 27. And this time I'm going to make that one. So this is 12, so it's about 50% bigger than that 0.08. So that could be like a 0.12 even. Whether they actually show up differently, we'll see. Well, what else did I guess I need to fix the layers. So that's going to go on this main layer up. V dash topo dash trees, I think is what I said for the other one. We'll switch the attribute layout and we will double check that layer name. V topo trees. Yeah. All right. So that has our two pine trees. And now we have this 18 and 24D. So, and if we look at that, and before we get to that, I'm going to go back to my edit my points and I'm going to look at that code for those points, which there's my pines, 12P, 8P. Here's one of the 18Ds, and I see it says 18D slash oak. And there's another one down here that's going to say, or 24D? I don't, yeah, up here, 24D slash oak. Okay, so the D code is going to be the setting the diameter, and the slash is going to be anything after the slash is extra description. So it would be, you'd have to have a code, one for 18D and one for 24D. And that sets those two. And basically you would have those as two separate codes because of needing to represent one as larger than the other, okay, in your symbols. Now there is another special category that has to deal with these points as being tree points only, and we won't dive into that aspect at this point. But if I looked at, let's go back to trees, and if I looked at this code called, let's see what they had for a tree. No, it's still set to topo. So if I had, let's say, well, here I've got oaks and pines. Oops, let me sort by, let's see. There we go. So I've got oak and pine, but nobody coded anything as pine or oak. That just happened to live in my code table library up to this point. What they coded was 8P and 12P and 24D and 18D. Now we could set those up with, there's a thing down here. If I look at my code table settings, I've got, let's see, not code table settings, but special codes where I've got my, no, let me look at that 24D. Yeah, these companion codes. All right, so companion codes are other codes that connect the line work with this current code, but they're not using the same code. So that's not really what I'm using, but I could find a code substitution, um, to do all kinds of things to help tie those things together. So right now they did not code a point as pine or code as oak. They're just using those. So 12D, 8P and 12P have to be a separate code, as do 18D and 24D. So 18D and 24D, I'll select those two together. Just shift click on those. And I'm going to use these buttons down here. I'm going to choose edit. I'm going to use that to keep them common to the different ones. So some of the things I'm going to change, like the symbol size, I'll make different for each one. But for now, I want to put this as a symbol. We're going to use a common symbol for an oak tree, which is going to be, let's use this one here. And let's say layer. So we're going to put that on a layer called the dash topo dash trees. Say okay. And we don't need, I think, much anything else. Yeah, so I'll say exit for those. Now I'm going to look at them individually and change their sizes. So 18D, if I look at my symbol, there's the symbol, and that point size, let's make it let's just make them, let's see, 0.18. And then for the 24D, we'll make it 0.24. Oops, symbol. All right, and let's see, while we're here, 24D, the full name, that's a 24-inch diameter tree. And then the description is going to be nothing. So that's what I should have done, was the description of those all together. So 24D, 18D, edit that. It's going to be an 18-inch diameter tree. Nothing in the description because I have the /oak that's going to be appended. So actually, that might bring up another. So an 18-inch diameter tree, let's call this 18-inch, and then we'll let the slash, so it will read now as 18-inch oak when it comes in. So that's fine, 18-inch. Black, same as 24. We'll call that a 24-inch, and it will say oak. Let's do the same idea for the pine trees. There's 8P, and right now we actually have the full description is 8-inch pine. That's all we need to deal with that in the 12P. That should be fine. And let's see, and just for consistency's sake, just so we know it, it's going to be an 8-inch pine. So now we have that in our full name category. Let's save our library. Let's exit and say OK. And now at this stage, you should see, there's our point number 1. You see that dual point, one for the fence, one for the concrete monument. But now it also says conc mon 4-inch diameter, and we also get the fact that it's part of a fence line. Okay. We now look down here, we've got an 18-inch oak, 18-inch oak, a 24-inch oak. So you can see it's a little bigger size. You see the description. And then in our pine trees, we've got a 12-inch pine and an 8-inch pine. Well, they're a little, I think, a little kind of tiny. So, you could go back to those codes and redefine the codes to make the symbols bigger. And you can also do a couple of things as we're working in this and looking at it. And if we come down here, let's focus on the driveway here for a minute. So I've got all these points, and what do I see right here? If I look at that as a figure drawing around, so if I select, first of all, that figure, if I choose the 3D polyline, you see all the little segmented arcs or chords rather around the arc? That's what happened with the 3D. If I select the 2D version, I can see just the endpoint grips and the midpoint grip. Okay. But what do I notice about that is that it's open. It doesn't close back on itself. So if I'm looking at this, I'm looking at these by point order, 27, 22, 9, 30, that looks good. Comes all around here. So it's 27 through 44 that defines it. What should have happened at 44? What could I have put on that code for 44? Remember up here on shed where we made that point number 7, if I double click that and look at it, it has a code called RECT that made it into a rectangle. What would be the code here? And think in terms of if you're drawing this as a polyline, you draw, 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 you get to here, and how do you make it close? You don't have to snap back to the start. You can just type C to close the polyline. And that's one of our codes, remember. So this point number 44, if I double click that, if it said PV space CLO, then that would close it. Okay. And that would be what we want to do. Now, I'm not going to do it right now. I'm just going to cancel that little edit, but I'll show you a technique that we have in doing these point edits as well. And it's under survey. there's draw field to finish, but come on down to this 2 commands below there, edit, or I'm sorry, not that, but the one command below it, the field to finish inspector. So when I do that, it's going to bring up this little split screen, and I've got different codes down here. And if I look at, a particular code, and right now, because I say zoom to, it's going to zoom to that area in our screen where we can find those codes. So if I come down to our PV codes, there's my pavement codes there. So there's PV. These are all the PV codes, and I can see the list of points over here in the instance counter column. So I've got 27, and it goes 31, and then to 29, and 34, 32, 37, 35, 44. Let me see what it is. That's an instance. Goes from 27 to 29. Now, why did it skip 28 in this first instance? And that's because 28 is not actually point number, or it's not actually the specific code of PV, because it has a code that tells it to start an arc. So it has PV space PC. Okay, so that's why you don't see that in that particular sequence. So that would be PVPC here, and then PV, and then PVPT here, perhaps, or maybe they just let it end after the third point to define that. I look at this particular sequence, so it goes 27, 31. See, if I look at my point list now, 27, 28, 29, 30. So that now gets all of them, 27, 28, 29, including the ones with the coding in them. Okay. So you can use this and go to specific points. And there's that point 44. I'm going to come all the way down here and just find that point 44. And right now you see the code is PV. So if I change that code, if I wanted to put a CLO as a command, that secondary special code to close, I could do that right here in this inspector, and I can say apply. And so what I'm going to apply is this change to point number 44. I'll say okay, and you'll see it now completes that as a closed figure. Okay. Was there anything else I wanted to look at while I'm here? Let's change I don't know, we can actually change the symbols from here. But we could basically edit the point. So that was a close. Now let's talk about one other one here on this building. I got a BLD code, so I'm going to actually exit this. Well, no, I might as well stay here. Let's look at our BLD code. So I'm going to scroll my code list back up toward the top and find BLD. There we go. And I have an instance that includes 18 and 19. I select that instance. I see I got point 18, point 19. All right. So this instant, 18 to 19, here's let's pretend this is the situation. This guy is out there surveying, and he sees this house over here, and he shoots the corner of the house, and he can't see this corner of the house because there's a big tree in the way. Now, obviously, he didn't shoot the tree, so we don't see it, but let's say there's something in the way he can't see the corner of the house, or it's walled off or something. The rodman can't get out there to it. So really, let's say the house is, we're just going to say 20 feet. So we'll go, so maybe he sees this corner, but he sees this, and he can't see the corner. He's just somewhere along that wall. But then he tells the rodman out there, "Roy, get out your tape measure and measure, all around the house." And so he goes from here to here, but that sets the direction, but not the total distance, because he measures this, and it's 20 feet total this direction. Or let's make it 30 feet. I'll give him a little bit more room. So it goes 30 feet, and then it turns this way and goes 10 feet, and then it turns back and goes another 10 feet. And then let's say it goes back another 15 feet, and then the back wall comes back up and closes. So it's going to be 30, 10, 10, 15, 40, and then close back on itself. So we're going to do all of this. We can do all of this with a special code called a jog code. And now I'm going to exit this right here for a minute. And here's what we would normally do is let's take this and just going to copy this right up here beside it. And then I'm going to explode it. So I'm going to just use my standard AutoCAD modify to explode this. And I'm going to now get rid of those three points. So this is what originally point 18 to 19 would have created. Now I've got a command in Carlson that is to edit, and this is to extend, if I can find the extend, I'm sure I'm looking right there. Here it is. This is extend, so I can, do this by distance or extend an arc or to intersection, those kind of things. So if I extend by distance, it says pick an arc line or a polyline. So if I pick, and I'm going to pick closer to this edge over here. And so now I get this little arrowhead and I see all these little options down there below as to uh, what these options could be, A, B, C, E, T. And I look at I'll type the letter H for help. And these are what these options are. If I type a number, that's the additional distance to draw or move than what it actually happens to be. So it can be positive or negative. So maybe I need to shorten the line or what have you. But I'm going to, look at that as when I type a number, that's the distance to add on to what is there now. But if I look all the way down, I see this as a total distance. So I could do that as a total distance that I know to be 30. And then I've got this left rotate and right rotate where we're going to, and we can put a distance on those as well. So here's how this is going to work. If I were doing this in the drawing and not as part of field to finish. So I would just have drawn 18 and 19. The field book notes would have showed the house dimensions. So I would say 18 to 19 as my code. Now I'm going to type T for total 30. So it's going to change the length of that original line to where it is now 30 units long. And I'm going to turn left. I'm going to say L10. So I'm going to left and go 10 units. Now you're watching how it's going. I'm going to go to R and do 10 units. And then I'm going to go L 15 units and L, and this time there was 30 plus 10, so 40 back. And now finally, L, was 10 and 15, so that'd be 25. Okay. And at that point, I hit enter to be done. Okay, so that's what the house really looks like, even though, and here's where it would be. Let's see, it's join nearest. All right, so this would be what you see right there, this point 18 and 19 would have been right there. He shot the one corner, he couldn't see the other corner, he only got part of it, but the measurements came back and said it was 30 by 10 by 10 by 15 by 40 by 25, okay? So let's consider that and look at our codes and see what we could do there. So let's go back to our survey, field to finish inspector. And there's 18 to 19. That was that BLD code. So let's go find that code. Here it is, BLD. There's 18 to 19. So 18 and 19. Now, just like we did with this line out here with the commands on the command line, we have a code for 19 where we could go to 19. So we're going to say that particular code. I'm going to turn off my zoom. I want to see it take effect here. So I'm going to go to point number 19, and right now I've got it set to be a rectangle 10 feet wide. All right, so that's now we know not the case. So I'm going to say BLD, and then I'm going to do what are called jog codes. So I'm going to type JOG. That's one of the special codes like RECT or like slash or like CLO. So I'm going to jog and I'm going to just give it a distance, and it's a distance ahead, and it's going to be a total. I think I'm getting this right if I remember it. So T30. So it's going to go for a total of 30 feet. And then I'm going to go space L10 space R10 space L15 space L40 space. And I think a CLO will close that. We'll see if that happens. Let's see if we apply it. We'll make that change. Let's see what it does. Well, that was obviously the wrong set of codes. I got it in there, but I did something wrong here. Let's see. I went, instead of a T30, that managed to turn and go 30. Let's see. Let's try an S for straight. That went 30 additional feet and then close. So the close is working. So we need to find out what that is to set that to be a total of 30. Um, so I'm going to, let's see, I don't think it's available here. No, let's look for, I'm just going to search for, let's see, jog. Try to find it, draw field to finish. Special codes. There's jog. All right, so jog. Oh, first of all, extend by distance. So it allows for a particular inserted drawing. Positive numbers indicate a jog to the right, and negative indicate a jog to the left. Okay, so that explains part of that first one. So alternately, R number and L number can be used. That's why we also had those. They worked. Finally, S can be used to make an offset straight ahead. So that put that by using a positive number behind, by using a negative number. So building jog S10 advances 10.1 units and then draws a closed rectangle. Right, always done in the XY plane. So I don't see that. Jog 20. So we would have to know. I don't have. I'm trying to think. If I'm in the field and I shoot that out there and I won't know that distance yet. So I don't know how to set that one to be a specific 30. But I think that distance actually works out to be 10. So if I make that just an, or 20, make that just another 10. Let me see what that looks like here. So that may be, instead of using those jog codes, yeah, that's close. Looks almost skewed. No, I guess that's it. So 20 goes 10 more feet out, turn, 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 and then close back up. So now it's created the house itself. All right. A couple of other things while we're here. We look at that Remember that electric symbol? And I said rotate to the forward line direction. So that's what that rotation looks like. Otherwise, the symbol, looks like that. You see, that's rotated to line up with that forward line. That's rotated. This one up here is, or let me get out of this inspector a minute so I can do a little better navigating. So this is, again, because there is no further forward, that's fine. Now, this is our electric line. And let's say we have a power drop from 17 to 7. So this 17, as we see that pole, we notice there's a feed for a power line over here to code number 7. So if I do this same thing for number 17, I'll go back to survey, field to finish inspector. Let's look for point 17. So I'm going to come right here and type 17 and then choose that go to point number. It finds it. It's a UP. That's utility pole 17. It has a code of UP, but that's going to also need a code of JPN 7. Join to point number 7. I apply that, and there it goes. Now, when it does that, up here in the drawing, this line that is, I can't select it until I'm out of here, but this line right here is the same line style as this one. You can't see it because the scale is too short to show the pattern. If I had changed this as 0.7 to join up here, so let me show you the difference. So if I take this code for 17 out, apply that, and then let's go to point number 7, shed rectangle space JPN 17, which we haven't shot yet in the field because we're at number 7 here. We would say apply. Now watch what happens when this happens. Well, you can't, let me change the colors of these layers. This layer is util telecom. We'll make that, instead of being white, let's make it cyan. And our shed layer, which we should have probably put on, let's see, we put it on building. So we'll make them blue and a little heavier. Or a building outline. Regen everything, show line work. All right, so now this particular line, I'll take that one out. Notice there, and I'll take this line also out. Okay. So I've got under here, if I freeze off, let's see, what did I change? Why is that? One's there, one's there. They're red colored. Why is this one white? Building. Back to survey, draw field to finish. If I look at my shed code, let me make sure its color is set to by layer. Structures, shed, edit that. Color is by layer right there. It says color white. Let's make that color by layer. All right, so that'll be that for that one. And we'll look at our building code, and it's going to be, instead of red, it's going to also be by layer. And the points have that color, and there is no 3D for that one. And the other 3D will be, what we see there, save and exit. Okay, and let it redraw. And so now there's our points. And I've got this blue building outline. I've got this blue, but there's another line above it, and that's this line. If I freeze this layer of my 3D polyline, you see that was making it look sort of purple. But this has this individual line. So the join to point number, remember I put the JPN code right here. So it takes it says join to another point, and it's using the line defined for that point. Okay. So if instead of doing that one, if I did, let's go back to my survey field to finish inspector, we'll go to point number 17. Instead of having this join to point number, I'm going to have this join to point number. So actually, I'm going to go to 7 and take that one out first. And so let's take out this JPN 17, just leave it as rectangle. Could have waited and applied them both. And let's go to 17 now. We'll find that. So UP is utility pole, join to point number 7. We'll apply that, choose that, and you're going to see that that's going to now use the line style of this point that's doing the joining. It's not the one you join to, but it's the line, it's the point that you're on, and you're drawing lines up to that particular point, and you need to join to a line. Now, if you happen to be working on a point that's not drawing lines, like maybe those trees or whatever, and you said join to point number 5, then it just makes a continuous line and probably on the same layer. I'm not sure what it would do, but that lets you, come up with those and fix those particular things. So now just a couple little more things to finish as to how you would do this. Let's take a look at those X shots, those random shots. So let's go to our survey draw field to finish and edit the code. And let's find these ground features at X. So let's choose edit. So this is going to be, spot elevations. It's going to be spot. And right now you see the attribute format is that piece of text. And they've chosen it as a text attribute instead of the attribute block. And if you go to that, the button next to it where you set your GIS notes and point attribute labels, you can see they're using the elevation and it's supposed to be to the nearest. Oh no, that's the rotation for that. So 0 rotation, and its position is 1, or its order is 1 rather, and it's going to. We can't change the position because down below here we're saying to use the elevation labeled decimal is on the point itself. And that's why you would see that like 498.23 is right on the point. All right. So me not liking that particular way they're treating that, I would do it this way if I wanted to use something with the points. I do like the tick. So I'll get this little X. But I'm going to switch this to an attribute layout ID of 3. I'll do a preview, and that's going to, when it plots, it's going to generate the elevation up at a 45-degree angle off to the right of that symbol. So that's what I'm going to want to do, and I'm going to freeze off those point number and the description when it gets time for that. So I think that's all I need for that one. I'll say okay. And let's go back to the trees and bump their sizes up a little. So my 8-inch pine and my 12-inch pine, I'm just going to double the symbol sizes on all of these. So I'll edit the 8-inch pine, go to symbol, and instead of 0.08, I'm going to make that 0.16. For the 12-inch, I'm going to make that one 0.24. And then for the 18D, I'm going to make that one 36. These are going to be huge. And the 24D, I'll make 0.48. So that's going to, yeah, that's really too big, but I'll show, just so you can see the effect of that. Now the 0.48, that's nearly a half an inch. So if I were to plot this little map, it would be nearly a half-inch tall tree symbol. But you can see the relative placement of those. Now it would say, save and exit, say okay, and let it draw. Now the trees are bigger relative. I'm going to change that the trees color to be green. The V road asphalt points, they're fine. We didn't really finish much talking about this down below. We got 2D, we got 3D. What's going on? And we've got points that are showing up because we want to see where the points are. But let's consider now what's going to happen here. Now, we could also, there's a separate manhole unit. So I've got a manhole there, a manhole there, and a manhole there. You know already how to make it draw lines between. And if it did, 52, 53, 54. Now, if they'd happen to be like, if this was 52 and this was 53 and this was 51, the lines would go 51 to 52 to 53. So they do go in point order. Um, so, make sure when you're getting these in the field that you're walking the ground and you're coding these points in the order as if you were drawing those points. Now, right here is a potential conflict that you've got a 0.45 here. It's the edge of pavement. It goes up to a 0.46, which is an edge of pavement. You've got 47, which is, or this is an edge of pavement PC. So that starts the curve. There's 47, which is EP. There's 49, 48's over here. We set the hub. 49 is also an EP, but in that case, yeah, still on the curve. And then 50 is an EP PT, or point of tangent. So I've got this curve, 2 points along it, setting that curve. But what happens right in here? They've made this driveway, this pavement here, to be a continuous enclosed figure, but they're overlapping the edge of the roadway here a little bit. What really should have happened is that this point should be double coded. So if I double code, if I look at that and double code that and make that point instead of just PV, it's also EP, right? So that will make that part of the pavement edge. This is also 34, part of this PVPC, but it's also an EP. And maybe put that one first because the PC is on the driveway side. So now that's double coded to say it's an EP. Here's the problem. This line for the edge of pavement gets itself defined from 45 to 46 to 47, 48. This one over here also gets itself defined from 33 to 30, around here, and then 33 and 34. So it picks up, and it would actually create a separate and other edge of pavement for this little end of the apron. And we really want this line to break and connect to those particular points, those particular corners. So instead of doing that here, again, that would have been the way, or more correctly, should have been 45 is EP, 46 should have been this point, is it's also, is 46 would have been EP space PV PC. Okay, but you couldn't stop and interrupt this one if you wanted that to be a closed figure. I normally would not draw this as a closed figure. I would have just come up on my way past, said that's now my PV, and then go around and set my PV until I get back to here. And now that point becomes PV EP, and then I continue on my merry way. That's the way I should have actually done this in the field. They did not. What can we do with that information? And how do we fix that information? Because usually we let this go ahead and create like it does, and then we make a regular CAD edit. So there's going to be some little cleanups that we're going to get in our work. And if we were to try to compute the volume, to compute a surface from this information, it will actually give us errors because it's going to have a crossing um, difference in elevation. If I take a look at this, I'm just going to select those few things. I'll go to my view, 3D view, drawing viewer. It's going to pop into here, and let's see if I've got enough of a difference to where I can see that. You see how one is, let me give it a little exaggeration here. And they're awfully close, but you can see they are, yeah, there you go. Now you can see the driveway edge on that, and the driveway sits above the pavement of the road, and it crosses it. So what would happen then is when you're doing the triangulation, it's going to flag an error there because this is a 3D line that goes over top of this one, and it needs to be trimmed back. So what I would do is go ahead and let it draw, leave the points where they are. I'm not going to affect the points, but then I would use this line to trim this line and then maybe cut them back just a little bit further as well. So I'm going to do that real quickly here before we try to model this. Let's go ahead and I'm going to pull it back. I'm going to keep it off the edge of that just a little bit. So I'm going to uh, I would still get a vertical difference instead of a crossing break line. I would get a vertical positional error. So I'm going to draw a line here. I'm just going to draw a 2D line. Um, no, let's do this. I'm going to offset. I'm going to go edit, offset, and I'm going to do don't really drift offset. I can just do well, let's do a standard offset. Now, again, remember, this has to be a two-dimensional line, and I've got double point. I've got a 2D line as well as a 3D line over top of these. I could freeze the 3Ds, but I'm going to be working on them. So I'm going to pick the, I'm going to say through as my choice. So I'm going to go through. Okay, yeah, I know they cannot be. Select. Let's go back to a standard offset. I had something selected I didn't need to do. So if I do a standard offset, there's my offset. I'll go through and select the object. So I'm going to pick this right now. I've got my multiples in place. So my selection cycling, I'm going to choose the polyline, not the 3D. And now I'm going to go here to a particular spot. I'm just going to put it right there, just so I'm a little bit inside of that. Okay, done and done. So now I'm going to use this line to trim my driveway, both 2D and 3D. So I'm going to say, so I select that line and I'm going to right click and choose trim. If I can see it here, that's not here. I select that polyline. All right, it's not in the AutoCAD version. The IntelliCAD version has it on the right click menu. All right, so I'll select that and I'll go over here to my modify and choose trim, which is right there, the scissors. So now what I want to trim is says, I've got that selected, so it's already done. So I'm going to now just click and choose the 3D, and I'll click again and get the 2D under it. So now that that's done, I'll now choose this original cut line and just delete it. Okay. Now I've got these two lines that are that's no longer a closed figure. I've got this to that to this to that, and they just end out here in the middle. If you wanted those closed back, you can simply uh, you can select this one, and then we need to join all of these pieces. So we'll do an edit, join nearest, and normally this has just a small gap, but we're going to say we'll just leave it like it is. And we're going to say, let's pick the first one and let's work on the 3D first of all. So we'll select that 3D polyline. And now we're going to select the other one. Okay, so now they're going to join as long as they're the same layer and the same elevation. We'll say okay. And it now says it joined two entities. So I've got that is now a 3D entity all the way around the feature. I'm going to join again. So I'm going to go back to near join. I'm going to pick this time the 2D polyline. There it is, the white one. And it looks like it is still all the way around. So that that one looks like it's okay. It's not in two pieces. I don't know why it stayed intact and the other one didn't. All right, so now with them both selected, I'm going to choose, I'm going to select them and select the properties where it says closed, yes or no, and I'm going to say yes. Now, what happened here? This one, the 3D, closed. It closed across the edge. This one, the 2D, also closed, but it closed as an arced segment because it was coming off of an arced segment and then going into an arced segment. So it just kept that also as an arced segment. Now, what do you do with that? And the simple thing to do with that is use our grip edits. We're just going to hover over that midpoint, and instead of keeping it as an arc, we're going to say convert to line. So it then drops back down and it's now a standard line. Now you can select that and put a concrete hatching in there for, a hatch pattern or something. In fact, it is selected now. Let's go ahead and hatch it. And we'll use our concrete. And of course, we don't have it. Okay, they've got a brick driveway, we'll say. Make it a 20 scale and a 45-degree angle. Let's see what that looks like. And we'll now just select the object. That's not bad. Let's change it. Pick or escape. So if we escape, let's make that let's add a few more degrees to that. Let's call that 60. Say, okay, now there's their brick driveway. We got a little hatching pattern in there. So that's what we would typically do in this. What happened to our spot shots? Draw field to finish. Edit codes, ground features, X. Oh, we went through this. It must not have stuck. I did change the layout ID. Maybe that never got changed off of the text attribute. So I'll say okay. Now, save and exit and do all of this stuff, and we'd have to go back and now I've got to go back and fix that again. There's those spot elevations. Now they're going to show up like that when we get to it, and then we're going to come back here and um, I double click. I don't want to recreate the boundary from that. I'm going to just draw a 2D from there to there. So I'm getting the endpoint. It's a midpoint. I don't want the man with the it is a hatch. All right, so when that opens up, associative boundary grips. Boundary retention. I guess since I didn't draw the first one as a associative boundary, I can't recreate the boundary just yet. So if I find I want the endpoints, not that endpoint. I want the endpoint of the fill. Looks like it's going all the way down there. Right there. That's the endpoint that I want. Well, in either case, let's just get rid of that hatch, and I'm just going to very quickly trim this guy back again, just to get him off the edges of the overlap here. So I'm just going to draw a point from there, or draw a little line segment from there to there. And I'm going to use that to trim my scissors, and I'm going to trim the 3D and the 2D. Select this, delete it, select both of those, change their aspects to yes, closed. Oh, okay, interesting. And convert that to a line. And now this, wow, that's why I didn't, that's why it did that, because I forgot, I neglected to join nearest on that one the first time because the 3D broke and the 2D didn't. So I'm going to choose that one and that one. Now they're joined. Now we select them both. They're both closed, and this one needs to be a line. So there would be, the way I would approach this is get Field to Finish to come in to draw most of this stuff for you, clear this stuff off, and then go through and do some manual edits that you're going to need to tie this together. One of which might be at this stage, we're going to maybe and maybe you would change that symbol, to an idea, but you know how to do all that now. But then you would maybe want to start turning on and off various layers as such. And so what I would consider is, let's freeze off our traverse layer. So we've got some commands under the view menu to freeze layer by pick. So if I just pick that, that took the traverse lines off. This is on a separate layer. If I pick that, now the points are gone. Anything else? Let's freeze the point number and point elevation. That leaves our descriptions. Now that messed these up. So we could probably change the coding there and keep the elevations on. So that would be, come back here to that point number. I'm going to sort by being frozen. So that was the point elevation. We'll turn back on. So the elevations are there. I'm going to change the color of my elevation attributes so you can see them better on the screen. So there's the elevations, the descriptions we keep on. If we freeze these, I think that gets rid of all those points. And because they're on a separate layer, they went away. We still see these other points, which is what we want. Now, if I freeze that elevation, I think that elevation also freezes. So I'll just leave those on for now. But you can control how that works. Now, the other thing that we would look at is I've got an iron pin found. Down here, I've got a point online. I've got an iron pin found. I've got an iron pin found. I've got an iron pin found, and it's got a concrete monument up here. Okay. So a lot of times what you'll do is, we don't know when we're out there in the field that those things are going to connect up to any particular thing. So I'm going to now find that frozen layer point number. I'm going to turn that back on just so I can use them. So we wouldn't know as we're surveying out there that we're going to collect, that we need to connect all of those up as boundaries. So a lot of times we'll come back in and now we know to go to, to connect our iron pins and check our boundary and see how that's going to work. And so, we would look at our layers. Let's see if we should have a V topo. Let me make a new layer called V dash topo dash prop dash BDY for my property boundary. And we'll keep it white. We'll give it a nice heavy line weight so you can see it. And we'll say, okay. And at this stage, I'm going to draw a 2D polyline. And we'll check on to use the current drawing properties. And I'm going to go from point number 8. Now, if I hover the mouse, see how that little target shows up because my point snapping is set to be on. So I'm going to go from 8. And I'm going to skip this point here. That's a point that got set on line. I'm going to come down to 9. I'm going to go over here to this one. There's 10. And I'm going to go over here to this one. That's 15. Whoops, I missed that. I'll put that back in a minute. And I'm going to come up to this one and choose point number 1. And I missed that one as well. So let me fix that to go from there to there. And this one, I'm going to go from there to there. Okay. So now I've got my, oh, I didn't want, I said to use the current properties, but my current properties weren't set correctly. So I go to my V topo property boundary. There it is. All right. So there's now my property line. Let's put that in the back. So it goes under the points. Now right in here, that would really, need to be an arc in there. And it is a 2D polyline. So, I would convert that to an arc and establish that, that would be what it would normally look like. Now, I went through that part and you see your point on line is right there. It's, and you could zoom in and see that it is or is not directly online, or you could measure the offset. Now, doing this way, setting that arc with an eyeball, that's not proper surveying. We wouldn't do that. We would actually resolve the boundary by using good survey rules of evidentiary procedure and priority. Um, but that's generally the way that you would do. You get field to finish to give you as much stuff as you can, and then you go make your additional manual edits. Now, at this point, you could, uh, let's say, triangulate and contour. And I think we'll just take everything as it is. Let me write the file. I'll select. I'm just going to call that EG. Let's call it F2F. EG, so we know what project we're working on. And we'll say no inclusions, exclusions, and no shrink wrap tuck-ins. So we'll say that. Grab our data, and it will build the surface. Boy, it's taking a bit. Too many crossing contours. Wow. So did some serious problems with my contouring. And I know exactly why. Just let it finish here until we do it. And I don't think it will let me escape it. Yeah, it's not. But I think what happened here is when I did it this way is I did not have that ignore zero switch on. So it's trying to contour this as a surface all the way down to zero. And it's looking like it's going to be stuck. And now it's going through and labeling the contours. All right, so this is a bit of a disaster. Now, if I find that that switch was actually on, I may have something else going on in this modeling. Maybe one of those points is not at zero. Maybe it's at some other non-zero elevation, but it's at the wrong elevation. Come on, hurry up and finish. Yeah. It'd be quicker just to kill it and come back. Okay, yeah, I think that's going to be our best bet. I'm just going to kill the process and recreate it so that we can get off this topic here. So I'm going to end task. And load it back up. Of course, I didn't save it, but that's the good thing about these tools that we've been using. All of that stuff got built with the exception of a couple of those little edits by field to finish processing. And there's the original that we had before. Well, let's see, what do we have? Join recovery. That one at 11:53. That was yesterday. That was yesterday. So if we take this one, it gets us back to that stage. Um, well, let's trim this driveway off again real quick. I'm just going to get myself a little eyeball trim line here. We'll trim this and this. Get rid of this. Join nearest in the 3D. And then select them both and close them. Convert that to a line. Now we're good to go. We would freeze by layer. And we wanted to get those driveway points. Let's see if we can get the roadway points. Those others we'll keep. We'll bring in our property line, our V. Site. Property boundary. We'll sit on that. As current, we'll draw a 2D. Use current properties, and we're going to go from point number 8, which is our F2F in class. So point number 8 to 9, 10, 15. All right, so 9, 10, 15, and then back to 1. And we'll turn this into an arc. Like good little surveyors, we just say, well, it looks prettier with the arc. You know, we don't bother to do any proper surveying work. All right, so now we've got that, and let's triangulate and contour. And again, we will write our file. There's our surface. Yes, we'll replace it. And this time, I need to make sure we ignore our 0 elevations. That's what was wrong. And contour to other contours, 1-foot intervals, that's fine. We'll say okay. Select our stuff, and off we go. There now is your contour map. No smoothing done, no particular edits, but that's your surface. Your labels, Maybe they're too close, maybe they're there, and there they got an awkward position. So I'm going to go to Surface Menu, and I'm going to go to my Contour Utilities, and I'm going to choose Move the Label along the contour. I'm going to select that particular item. See if I can try that again. There we go. Now, let's put it, say, there instead of right on that corner. And there you go, as the English would say, and Bob's your uncle. So there's now your, the official contouring of this. We can see there's all kinds of additional controls that we might put. We might freeze off point numbers and leave elevations. Um, and finish up our map and saving a significant amount of time as we're going through it. Okay. So with that gets us to here. We'll save our drawing. We've got our F2F in class. I'll just let it replace that one since I messed mine up a minute ago. I've got a surface that we can examine very quickly in our 3D viewer. Looks like that. So it's not a really rigorously defined surface, which I can see, I've got some of these long skinny triangles here that are causing those triangles to bend as they cross those areas. Part of that's due to the fact that this has a 3D line, and that the only other information it finds in 3D is like over to this point, over to this point, and to this point. There's no other edges in here to try to give it some uh, relief other than going to these single points. And these long triangles here, you see, that's the only, and they're not connected by lines, they're just connected by points. So if there were 3D edges in there that we could densify, we might add some break lines and densify those break lines and clean that stuff up a little bit. But again, for the purposes of what we're doing to illustrate, um, we wouldn't go to a lot of effort to make that happen. So, and there I've got another, and just like we did this point drop for this, we can simply come in here, and I'm going to be on that layer, which is VU telecom. I'm going to say, make that layer current, which is one of these. I'm going to set the level by selected entity. So if I set that, let's just, what is it? V util telecom. There it is. I'll double click. I'm on that layer, and I'm going to draw a 2D polyline now using that current drawing properties from this point, which is here. Shift right click and go perpendicular to here. There's no pole that we saw that connected to. So that light pole had a power drop from the main electric line going across the edge. So, that's how you would wrap this stuff up. Now, this edge of this pavement, for instance, could have even, included a curb feature, and we only really shot the one. So if we're looking back here, we actually did that in this example, that we took the edge of the pavement and we made it into a template that said, all right, throw down a 3D line here, but also go over 12 feet, put a 3D line at a 2% grade, go over another 12% and put it back down 2%, create a 3D line at that stage. And so that will color that stuff in. Okay. So that's really where field to finish can help you streamline what you're working on. All right, so that's and then for some further work, I'm going to refer you on your own to really start to investigate it with these other two books and data sets that you have in your delivery. Okay, and now there's a whole bunch of stuff to do to run those. You change your overall configuration and your your general settings, and but they step you through every bit of it right here, and they tell you to save off your currently assigned ones and set these up. So off you go with that to study on your own, and we'll put this topic to rest in terms of all the complexity of it there. And then when we come back up to lunch, I haven't forgotten about lunch. I do apologize. We've blown right through your morning break, and we're pushed a little bit past our lunch boundary. So we're going to fix that here in just a second. But what I do want to show you is also another technique with field to finish, and we'll do this after we come back, but we're going to do a field to finish, what we call on the fly field to finish, where we don't have a code library, but we can use it. We know we want to make something uh, work with field to finish, um, but we don't want to go through all the investigative stuff to try to make something special. And we're just going to use it to help us define something a little better. Okay. And that'll take us about 15 minutes after lunch to look at that. Then we'll be on the deed stuff and wrap up the end of the day with a little subdivision work. All right. So with that, it's 20 after. If anybody has any questions, I will gladly entertain those. But let's come back at 20 after 1 and we will reconvene for that. But no questions? I will see everybody in an hour. Let's see here. Sarah, you and Scott, who have been so good to catch me, I will remind me to, I just now restarted the recording. So now we've used field to finish in that last example to help us generate a, to go from basically nothing to create the bulk of the finished drawing for us. Again, based on the way those codes work. Now, field to finish can be very frustrating and easy to give up on if you have people who do not embrace it and work, work to the same ends. For instance, I had a friend, later became a client actually when he started back up his own surveying company. We would settle this up and he'd train him how to use it. And then he would go out in the field and he would do things like, instead of, let's say, to take the edge of pavement, for example, instead of putting down, here's an EP point, he would use the EP. He knows he's, getting the same codes and edge of the pavement. But then he would, occasionally would slip up and he put EOP. So that's a completely different code. So it didn't connect. And then he would put things like, he had a real habit of doing things like EP, and then he would put PC to say start the curve. And then he would go to put a point on the curve, and instead of just calling it EP and wait and letting the software decide that it's on the curve because it later finds an EPPT, he was in the habit of labeling those points as EP and then POC, which told him it was a point on the curve. Okay, so that was another code or a special code that didn't exist and it wasn't ever working for him. And he was always inconsistent with whatever he would do with that. So he really had a difficult time trying to make field to finish work. If, however, you can get those codes built and teach the people in the field how to do the coding, and have them understand that you need to think about this as if you are drawing the map as you are out here in the field. So don't just randomly jump all across the way, getting the edges of the road. Start on one end and go to the other end. You don't have to do all road shots end to end and then do something else. You can interrupt it and pick up, a manhole and a tree and a fire hydrant and a building and another feature as you go, but just make sure you get the points you need in the order you need them, as if you were drawing them connected together by the same code name. And once you get into that kind of habit, you're going to shave days off of the workflow because you're not spending all that time playing connect the dots. Now, there's still going to be some things to fix. There'll still be some boo-boos, and that's fine. Now, the other way of using field to finish is not just with that when you do our field work, but sometimes even on just the design side of things, we can use it to help do some heavy lifting so we're not having to sort of pick our way around figures with figuring out drawn lines and things of that regard. And it's what we call field to finish on the fly. And there's an example of it, and sometimes it works for us, and sometimes you'll get some weird results, like the points are out of order, things like that. But if you look on page 70 in your manual, let's step through this one very quickly and see how this can be helpful for us. So if you just start a new drawing uh, of your choice, and then we're going to open up a coordinate file called manual topo.crd. So I'm going to come from here. Let me save that and close. Uh, oh, I see. Close that off there. Now we can save that. So, yeah, so now we'll close that one and we'll start a new one. And I'm just going to call this one. I hit my set button at the top, make sure I'm in my folder. And I'm going to call this one F2F dash, well, get it right, F2F dash on the fly. And we'll say next. I don't need a projection. It's just arbitrary coordinates. I'm going to say no import, but I will choose the file. So I'm going to set my coordinate file to an existing file called man topo. Make sure I'm in my folder, my data set folder. Look at man topo and choose open and say next. I'll verify my points. I'll go to my points menu and list the points. Whoops, that's draw locate, which I'll do at some point. But I'll list the points, list them all. And I see some points here. I see a bunch of codes. Looks like somebody's done some work on this actually with start and stop codes, which you could maybe have to go in and put those in for you if you wanted. But these codes, and if you look back here on this page in the book, you've got three different descriptions. You've got ground/shot as a code. You've got some that say 17 and some that say 18. And 17s are all on the tops of the banks and 18s are on the bottom of the banks, but we don't necessarily know that. So we can see all these different shots there. You notice there's some begins and ends. So we have the idea that they're intended to be used in that regard. Okay, so let's see what we have. Let's just dump our points. So we're going to draw locate points. And we'll just take our defaults like that and choose draw all. have them draw the points, and there they come into the drawing. So this represents, a big open field with some things around it. And I look at these particular points and I say, well, these are all in the middle. They say ground/shot. And I got some out here, got sort of clustered around the bank, and I can see I've got, ground shot, ground shot. Here's a 17 to 18 to 18 to 17. I look down here, there's a 17 to 18 to 18 to 17. And looking at their relative elevations, let me set that color up so you can see it a little better. And let's see, let's try that again. Where's that point elevation? Oh, PNTS elevation, sorry. And let's also fix the text style so you can see it. Choose that P text, and I'll use that Calibri light. All right, so you can sort of get a sense looking at this. I'm looking at the relative elevations. 13.6 is higher than 12.1, is higher than 12, is less than 16 over here. So these are all sort of looking like some kind of a linear feature around there. And here's why they're important to do it is we're building this into a terrain model. Let's go ahead and do that. Go to the surface menu, triangulate and contour. And for the triangulate tab at the top, we'll write the triangulation file. We're going to select, and we're going to call this one EG, excuse me, EG dash man topo, just so we keep it straight what we're working with. And make sure you have ignore zeros on. There's no break lines to densify here, really. We can leave that on if we want. And then we'll draw the contours, and we'll just take the defaults on those. And let's label those every 250 and not 120. All right. So we'll say, okay. And now we're just going to grab our data and see what resulting contours happen. Well, there they are. Look at these here as it goes through what are supposed to be ditches around the outside edges. And that's because when these triangles form, here's a ground shot on one side of this ditch, and over here's the ground shot on the other side. So that formed a triangle. It's just straight across because there was nothing in between to break that triangulation. So we need the break lines. We need to basically connect, say, this 18 to this 18, the 17 to 17, 17 to 17, 18 to 18, that sort of stuff. But we haven't done all that. You could spend, quite a few precious amounts of time, minutes or hours or whatever, by going through and editing your surface and manually adding break lines. You could do all that. In this particular case, it wouldn't be that insignificant. So I'm going to erase my contours. I'm going to choose erase by layer. I'm going to select from the screen, and I'm going to get one of the labels, one of the index, and one of the intermediate contours, and hit OK. So they're now gone. So you could start drawing 3D lines, 18 to 18 to 18 to 18, 17 to 17 to 17 to 17, or you could look at the point numbers and figure it out. Or let's just use field to finish to do this for us on the fly. So let's go back to our survey menu and choose draw field to finish. And we're going to draw points. And this time we're going to come down here where it says this code table at the bottom. And we're going to change the name of the code table. So we're going to say set, and we're just going to call this temp. It's just temporary on the fly, except I'm going to spell it right. He said, T-E-M-P. There we go. So I've got an empty code table. It does not exist. Create it now. Yes. All right. So there it is. Now it knows it's empty, so there's nothing. It pops this little convenience up for me. I could do it from here or not. So let's make a code table by the point descriptions. So it's now populated that. I'm going to edit those codes, and I see I have 17, 18, and ground. Because remember, the description was ground/shot. So that means go to those, add shot, because that's the part that's after the slash, to whatever description ground has. I'm going to edit ground, and I'm going to take the description out because I don't need it to say ground. It's just going to say shot. And it's going to be points only. That's going to be fine. And now edit on 17. And what do we say that 17 were the tops of the banks? Whoops. Get that over, now that over. So on the description, again, I don't need a description. I don't even need a symbol. So that is now set to be nothing, be blank. But line type, I'm just say by layer. And on the layer, I want to draw a 3D polyline. You don't need to see the other lines. And you can keep them on those same names right there just very quickly. Or you could just call that, that's going to be on a layer called break line. So we'll call BRKLN. We'll say OK. 18 is going to be exactly the same. We'll take the description out. No symbol, just a 3D polyline, and we'll put that on BRKLN. And we say OK. We save, exit, OK. And now you see how the break lines all got magically drawn for us all at one time. And there could be some crossings. You might have to do some tweakings up here a little bit. In fact, maybe that little segment is not necessarily supposed to be there, although this 52 is 17, and then it joins back up to here. So maybe this segment, this one was the 51 to 52. Over here's 53, which is another 17. So that could have connected to 53 to 54. But I think 53 is an 18. It is, yeah, that starts that. So, you could do some tweaking in there if you wanted to, and you don't have to go back and do it again with the codes. You can simply say, well, let's take let's just do an edit, polyline utilities, remove polyline segment, and let's just take these two little segments out right here. Okay. Now, if we run field to finish again, we would need to fix the code that drew those lines. But now, since they're drawn, we can just leave these as they are. But this is going to prevent some of that stuff from jumping across and seeing the other points. Now that point 17, or that point 52, which is right there, it's going to connect up in here. And so maybe you still need a barrier across at one point. So there's 53 to 51. So let's maybe draw that in. So we'll just simply draw a 3D polyline. And let's put this on our break line layer. And let's go from, say, 51 to 53 directly. And we might even do it again as from 50. Or do we need that? From 50, yeah, 50 to 11. All right, so that'll sort of isolate those points away from there. So we've sort of cleaned up a little bit of the stuff in there. And you might even could take this segment, instead of going from 10 to 158, perhaps that went like, see, we don't want to cross. Maybe it went over to here, but see, that would still maybe, let's do that. Let's go to, if I can get it to catch, there we go, to there. All right. So now we've sort of done our manual cleanup. See that we've got something to go with, and we will now go back and redo our surface triangulate and contour. making sure that we have down here too on our triangulate tab that we want to erase previous contour entities. Let's say, yeah, let's go ahead and choose our current entities. We don't have any, I've already done it, but we'll take this, say it's okay to overwrite it. And now we grab our data, hit enter. And now look at the difference in the contours. When that ditch is pretty nicely well defined, we can see that by viewing our surface in our 3D viewer. Let me turn a couple of things off here. I don't need to see the triangles. And there now you can see that those ditches formed the way we were expecting. Okay, so very quickly, and it goes all the way around the outside edge like that to the corner. So that would be a much better representation than when we had all that jumbled up mess where we didn't have the break lines in there. And let's see, so now I'm going to freeze. I'm going to freeze these. I think that was the layer of the break lines. Yeah. So there now is going to be our resulting map of this site. So it's a lot, you know, a lot more representative of what we have because we use those break lines because we connected all of those things up using field to finish just that quickly, just building one on the fly and ready to done, you know, deliver your product. Save that file and we're done with that. Okay, any questions on field to finish that may have occurred? Because it gets really, you know, it can become very much more complex than what we've done, but can save, therefore, correspondingly more time and be more efficient when we're doing our work. I had an example of a guy who came to Pittsburgh to take the class and came up from, I think he was from a company somewhere in Eastern Virginia, down on the coast somewhere. And he was an older fella, had his own company. It was basically him out there, but he was doing things with field to finish, like using it to establish, you know, how to establish like like pavement marking arrows, like get the back of the arrow, get the tip of the arrow, and then have it draw the symbol in. So he's not trying to get, you know, he doesn't get every point of the arrow. He just gets those 2 points to set the orientation, and he puts the symbol in, it scales it accordingly, and it rotates it accordingly to those 2 points. And his amazement was, you know, he goes, man, that makes the trip worth, you know, that right there makes the trip pay for itself because that was going to save him so much time. So he didn't have to fool around editing the drawing. Field to finish would take care of that for him. Okay. So if no questions, let's jump into the survey side of things with, well, although that was on the survey side, but let's talk about this deed processing. Now, we're not going to actually do this particular exercise. It's there for you later if you want to try it, because I'll tell you quite frankly, it's there, it has the capability, but there are too many inconsistencies in actual practice for this to work well. Because what you have to do with this, and this is and again, the files are there for you to do this exercise on your own, but it's just going to take too much class time. But what it does is it gives you the capability of reading text into a field or into a little frame here. So you can see that is the description from a deed, beginning at a pipe on blah, 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 and thence with the line, blah, blah, blah. So it goes through here and it identifies what it recognizes as bearings and distances or arc information, uh, point to point, you know, what like you know, an iron pin set, that kind of stuff. But you have to set up in their settings a bunch of codes that say, well, you have to look for the the letter S or a degree sign, and you have to do something and you tell it, and so when you see a deed bringing in here for that to work, that has to match the same format. So maybe the bearings have to come first and then the distance. And what happens in actual practice is you'll get a description that might say in one line, thence blah, 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 S space 64 degrees space 19 minutes, or, with or without spaces, 00 seconds, W, 209.20 FEET to another point. But another line, you might see NORTH 27 DEGREES, and then it might say 104.14 and then foot symbol instead of the word feet. So because of the inconsistencies, even in a single deed, you really wind up chasing your tail around this thing for much longer than it would take to just draw the deed. So, but it is there and it does work if you get a batch of consistently described properties. So it can be very helpful in that regard. So it will parse the descriptions and build the deed right from those descriptions as long as you match those settings. Okay. And you can see that, in fact, if we had a new drawing file and then we went and read that deed text.txt, just to show you where that is, let's just call it new. And we'll give it a name in our folder. Just call it deed reader. So I'll show you where this is, but we won't take the time to chase it all down. We'll say next, and then this comes up just next. So now we've set everything together. We've set a coordinate file, and I'm going to go to survey, and I'm going to choose deed reader. And right here is where the text would go. So I'm going to come down to the bottom, and I'm going to load that deed text.txt. So I have taken that. Now you can use a a Microsoft Word file. You can open it up, you can copy and paste into here. And there you can see where it starts to read that deed, beginning to pipe on the Wesley side, et cetera, and it goes on over this way. And it tells you down here some warnings or some errors, and it says your first one, it found an unrecognized entry beginning at a pipe, blah, 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 and that's up here in this first one. So all the unrecognized, you see the red text, it recognized the word west, but then did not recognize ERLY side. Down here, it recognized the bearing, but not the distance. Okay, and so that is controlled in your settings down here. So you would look here. So for distances, you would say, all right, I need to match, that's a foot symbol. Or you get inches and meters if you want them, chains, default units, prefixes, etc. And you can give it a particular warning to show up here or a warning color. Same thing for bearings. So you have these different possibilities and arcs, the same thing, thence with a curve and all these possible things that you can use. So without taking the time to, we would normally would go through here and match all of that to clear out all of these warnings. And as those warnings are cleared, you would see the deed actually start to take shape in the drawings here. Now, I don't think if I've got, let's see, quick distances settings. Yeah, if I load, maybe I had a pre-built settings. Here's my deed reader settings. So I'm going to load that one up and you'll see some difference come in here. So I've loaded up one that I'd previously done. I hit OK. And so now here's what it found, but it still had these. Here's that particular warning. It found this unrecognized entry beginning at a pipe and a blah, blah, which was basically the point of beginning. You could ignore that. And then it went south at 64, 19 west, 209. 20. So here it says, while reading a line code at a position of line 2, column 37. So I'll click up here, and at the top, you see I'm at line 2, column 32. It's going to get over to right there, column 37. And it says, while reading line 2, column 37, it found a line prefix that has a value of thence. So back on the start of the line, the word thence tells it you're starting a line. And let's see, what else does our little warning say? Found a line prefix with thence, searching for a line distance and a bearing. Found an unexpected S with the value space S space space. So check that the text contains. So you would go back to your text and you would look here, and you can even, at this point, you can edit this text right in this field. So I'm going to change these to make sure they are just individual spaces. And then I've got to look at my settings for bearings, make sure I've got, see, I don't, there's a space S. Maybe I put a space in front of that and a space in front of that, space in front of that, and a space in front of that. Let's see if that clears that up. And we say, okay, and did we clear that? We process the text. And we go back to the top, and it still says, found an unexpected S with a value. All right, so it's searching for a line distance and bearing. Looks like maybe it was expecting the distance to be first. So if we look at settings, let's see, distances have the value feet. All right. Bearings, we have those. And let's look for angles, what format. So I'm using the degree symbol, minutes and seconds. So that part should work. And I see up there the colors are matching okay. But then if it's looking for a distance first, perhaps, let me come up here. Change that to, if I control X, and then I'll come over here to, get the right arrow key, control V, space, and now process that text. And, oh, it looks like I put it in the wrong spot. Ah, let's see here. Control X. Let's go up and click right there and control V, and then process that text. So you see now it's still, let's see, it still found that value of S double space, S double space, and that's on line 2, column 48. So here's line 2. Let's go to 48. And they look like single spaces. And, oops. Yeah, so see, you know, what did it find here on line 1? Found an unrecognized beginning. Okay, and then it went on there. So more settings for lines and arcs. distances, bearings, azimuths. Line starts with thence, ends with a semicolon. So if I look at here to the ends, I've got semicolon, semicolon. So that first one, let's take out that semicolon. It still has a problem with that beginning line. So anyway, you have to sit here and sort of chase down all of these things that could cause these warnings to come up and clear them. And once they clear, they'll draw. Now you see some actually did draw because it recognized, some of these as it created it. All right. So that's the process. And that's why I say we're not going to, we could sit here and go through the entire little, and it's a small deed. It's just a little four-sided deed. So you can see how that could be kind of laborious, that you may or may not want to um, have it do that. But it gives you some nice little summary statistics like your closures and areas and things like that once everything works. Do I have any quick settings? There's a suffix, and then lines have a prefix of thence, a suffix of that. Line distance, suffix. Uh, distances. There's my suffix. FET. Process that, and now that really screwed it up. Found 2 and 1, found line prefix of this and a distance and a line suffix with that. So it missed, everything about that line too. So as you can see, as you chase that around, it's just going to take too long to do that stuff. But if you have a consistently, if your deeds that you're working with have a nice consistent format, they're in the right form and they're not jumping all over the place, which if you've ever worked with deeds, you know that they are never done consistently. And so that would be how they, but that could, save you some time. If you're abstracting a bunch of deeds from a subdivision, for instance, and they're all generally created by the same surveyor or attorney, excuse me, and they're all in the right form, you can use that to help you read some stuff in. So seeing that as the process, let's go next to this, um, to our next little example here, and that's how to actually process these deeds. So that was our deed reader. And then the next step we'll do then to work with deeds is we're going to draw this figure based on whatever the deed is, but we're going to manually enter it into the system call by call and let it create it, and then it will save it just like a raw file saves our Kogo work. We can use this to save our deed description and then replot those and reuse them later on in other work as well as we've saved those files. So we're going to go next to the enter deed description command, and we're going to enter in this particular set of deed calls. And I'm going to just do a little capture here, bring it up on my other monitor so I don't have to keep flipping back and forth. All right, so back to our drawing here. Nothing in it. We do have our coordinate file. Let's change our coordinate file. We're going to pull this down, say points, or let's see if there's anything in it. List our points, all points. No, no points. So we can just keep this one open. And let's go to survey And this time, instead of deed reader, let's enter the deed description. It's the line above that one. So here's the way this is going to work. We're going to specify a layer for our lines and curves and a points layer that has where the points are going to live. And maybe on this line and curve layer, I may call this deed dash lines. Or maybe line work, because there could be arcs. Let's call it deed line work. Points and deeds. I'm going to traverse by, that's in other words, I'm building a traverse around my property, either be prompting, or if you know they're all bearings, we can switch to bearings, which we do. And the point format we're going to use are either just descriptions or no points, or let's just make complete points. And we're going to generate points as we set these things down. We will tell it to label the lines and arcs. And right now it's just using our default line and curve labeling, which is fine. You could change it and edit it if you'd like. And we're going to call this deed. We'll give it a name. We'll just call it lot 1. We'll tell it we want to draw the line work. We want to create a polyline as we draw around it, so it's a single consistent line. You can prompt for descriptions when you get to points if you want. We'll leave that on. We're going to store to a deed file. Now this down here is where the payoff happens. We're going to save this to a deed file, and right now it's set to new. And let's choose set, and we'll stay in our folder here, and we'll call this one, deed entry. Okay, and that'll be a new file. Now you'll see in a minute, we've got the file is already built from a previous run of this as well that's in there you could look at. And then, like if we were to do this for another lot, and we want to keep adding to this deed entry file a list of separate deeds, we would change this from new and mark it as append, so it adds into that file. But right now we've got deed entry, it's empty, it'll be new, it'll take this lot 1. So let's say okay. All right, now, if we look at our figure in the book, we have a POB indicated. Let me see, enter the point. Description, that is going to be our, I'm just going to call it POB, hit enter. And now there it is starting right there. And it's wanted me to enter a bearing in the format of Q dd.mmss, and that the Q is for a quadrant. And the quadrants are just clockwise around the clock. Northeast is 1, southeast is 2, southwest is 3, northwest is 4. So my first call is northeast. It's north 25, 30, 45 east. So that's going to be a quadrant of 1. And then I put in the degrees portion, 20, and a decimal. And now the minutes and the seconds. So 3045. And if you had partial seconds, you could keep typing, etc. So that's now the bearing it's going to go. And I have to put in the distance. Notice you have all these other units you can use, varas, meters, rods, and chains, or in angle brackets, it says in feet. That's my default. I just type the number 165.45. I hit enter, and it wants to know a description, and that is, I'm just going to call it COR for corner. Now I'm going to zoom out and come in a little bit. There it is, labeled, and there's my first leg. Okay. It's now asking me for the next bearing. Well, this one is south 45 east, so that's a 2 as a Q code. 45. Now I don't have to put the 0.0000. That would be all I need. And the distance will be 200. So there now is that distance. And it's going also to a COR, and that is the last used description. It's in angle brackets. I just hit enter. So now at that point, my next call around there is quadrant code 3, because it's southwest, 25.45. 3030 if you want, not necessary to finish it if it's a trailer. And it has a distance of 156.78, but I'll show you something here. If I typed it wrong, if I did 165.78 instead of 56, we'll make that as an edit point later. And it's also going to be a corner. Sorry, so I'm working my way around, thinking I'm in good shape here. And at this point, I encounter a curve to the right. So I'm going to type from my options list down here on the command line. I'm going to type C for curve. And it wants to know a radius, or I can use the curve calculator, do a tangent out. But the radius on that is 200 feet. And which direction, left or right? Well, I'm walking around my property here. It curves to the right. So I'll type R or a plus. And it now wants to know the arc length. If you happen to know that, you can have those other items if you knew what those were instead. So the arc length is 175. Hit enter. So now that's drawn that. It goes to a corner. Again, I'm going to call that one, change the description. We'll call it PT to match the book. And now finally, or not finally, but next to finally, we're going to go quadrant northwest, which is a Q code of 4, 10 degrees, 0.1525. So 15 minutes, 25 seconds, a distance of 200. And that goes to, again, we'll keep the PT as the description. And then finally, what should be our closing leg, we're going back to northeast of 25, 40, 30. So that's a 125.4030, if you wish. And that's going to be a distance of 49.3 feet. And that's now back to our POB. We hit enter. And now it keeps asking me to keep going, keep going. I don't want to keep going. Now, you also don't want to hit the escape key because that kills everything you've done. You want to type E for exit. So when you type E for exit, it does so and finishes that. And it says, unable to open the file. Let's see which one. deedreader.rw5. Oh, okay. Which I can, and this is select objects. I'll just hit enter. It was trying to open up a raw file that would have kept that going. I don't know why it wouldn't allow it to be open, whatever, but that's due to on my settings. Carlson configure survey settings, I think had that automatic raw file was turned on. I think, nope, it was off. I know, don't know why. Edit process raw data, did it? Didn't generate it for sure. So, all right, so that now has my deed in it, and it looks okay, except I come up here and I say, whoa, 0.7 is supposed to be 0.1. I missed it there, obviously, by a distance. Well, what is that distance? I'm going to do a quick COGO, an inverse, and I see that letter I right there in parentheses. That's my shortcut. I could just, on the command line, just type, let me type I, enter, and it wants me to point to point. So I'm going to go from 7, enter, to 1, enter. And I'm going to look at what it tells me. That was a distance of 8.989 feet, so almost 9 feet. And my, did it give me a bearing? Yeah, north 25, 30, 39. Now, what do I know about figuring out errors? If I look at that north 25, 30, 39, I'm going to zoom back out here and I'm going to look around and see if I can find, oh, look at there, 25, 30, 30. My results were 25, 30, 39. It's roughly parallel to that. So maybe there's a a distance difference in here that I mistyped. Now that's supposed to be 156, not 165. All right, so what do we know about transposed digits that are next to each other? The differences are always going to show up as factors of 9. So I look at this distance in my inverse and it was 8.99, so it's almost 9. So that would make me suspect a distance error by transposition, either in this line or in this line. It's nearly parallel, maybe this line as well. So I would go back and double check that. So let's say here we found it. That should be, I look at my D on paper and I say, oh, I mistyped that. So how do you fix that? And you don't just edit that text, which you could certainly do, but all you're doing is changing the text. So we need to edit the deed. And because we saved it in a deed file, let's go back to survey, and where we entered the deed description was how we just did what we did, but we want to now process the deed file. So when you choose that and you choose, there's our deed entry file that we just made, we open it, and there's our lot 1. I can see that. You can hit the edit button or just double click it. And now you can see the numbers, and this lets you change a particular call around the deed. And there's the one we want to edit. So we sit on, let's see, where was I? Here. And we want to change that distance from 165 to 156.78. So I'm just going to edit in that field. And I'm going to take out that 65 and make it 56. Hit enter. And now you should have seen down here in the graphics, you would have seen that close up that gap. And so that looks better. Now you've noticed I've also got my quadrant codes here and my bearings here under different columns. I can change that over here. Instead of a 3-column, I could have it as a single 1-column, to where this is the way I entered them. So that's just a display convenience for you. All right. And so all of these things you can check to make a curve tangential. You can change directions, etc. Now I see that's now supposed to be an arc, which it is, now why do I have an arc here? Oh, I think there we go. That's a line, not an arc. And this should be an arc to the right. I guess when it recomputed the line coming into it, it screwed that part up. So I'll go back and put this part in. The radius is going to be 200, and the arc length will be 175, and the direction, of course, is to the right. So there now, everything's back the way it should be. I'm done with that. I'll say okay. And at this point, I'm going to hit save. So I've now made the edits to that lot. And again, you can add another lot, like lot 2, lot 3, lot 4, and you can have them all here together, and you can edit those individually. You can select one and report on it. And when you look at the report, you can look at the precision, the distance units, etc. And here's our report. This is starting at this coordinate, looking at using feet. Here's my calls. Here's my descriptions. The ending coordinates of this compared to the beginning. That computes our closure. We misclosed by 1 in 84,000, and the closing distance was 0.01 feet along that bearing. Certainly close enough for a lot of deed work that we might want to do. Okay. And you could have other, that starts us on our way to resolving this deed, if those are in fact the points that we used. Now, we still have this up here where this point is still down here, this point's down here. These were the original entries. So that really wasn't where they should be. So what we will do is I'm going to redraw that deed. because again, this draw is left over from our entry of the deed. We edited the deed, and so let's go back to that now and say survey process deed file. We open up our deed file, we select that and say draw, and we're going to use the lot name for the layer. No need for that. We'll put the deed layer on deed line work. And we're going to erase previous deed drawing. We'll label the point descriptions, label lines and arcs. Based on the defaults, we'll say OK. Everything goes away, and it comes back and finishes that, and we'll exit that. Now look at our points up here. The line got corrected. The point did not. That point did not. This point did not, because this distance was originally off. You see where that point is supposed to be? So these points all need to be shifted back. Now that particular point there managed to compute at that original endpoint. So you would simply move this point. So I'm going to move point 4 if you wanted to do that. I'm going to go to my points menu, adjust coordinates, and move a point. So I'm going to select my point 4, position for it. I'm going to come up here until my endpoint snap comes up and move point 4 to there. I want to see, here's point 5. It's down here. It needs to be up here. I said originally it didn't move, but it did. So let's move that. I'm going to repeat my command, move point 5, and it's going to go up to that endpoint. And I'll now move point 6 up to this. I guess I have to repeat the command again. Move point 6 up to this endpoint. And I'll repeat and move point 7. Now, make sure you get the endpoint of this line and not that line, because that is slightly in a different location. You see them right there? How there's a little bit of overlap. If you're curious of what that is, you can eye to inverse between 7 and 1, and there's that 0.01 misclosure that you can see. The distance is 0.0107797 along that bearing. Okay, so now you've got some points. Now, it's going to lead us into our next little exercise, and that's called our deed correlation. So how do we do something like that, and what is its purpose? Well, you have this drawn boundary as a polyline. So I want you to select it, and then just right click and choose copy selection, and just drag it out here to the side somewhere as an extra copy. Now let's change this and call it, I'm going to put this on a new layer. So I'm going to make a new layer, and I'm going to call this one field instead of deed. So I'm just going to make a new layer. I'm just going to call it FIELD. And let's make it yellow. And with that selected, I'm now going to pull down that layer in my properties, and I'm going to choose field. So there it is. Similar type of feature, but I have, again, right down here, I've got that sort of double overlapping little thing. So I'm going to zoom in. I'm going to grab that grip, just going to snap to the grip. I'm going to stretch it down. I'm going to close it up to there. So I'm going to sort of force that into a closed figure, just because I know there's only going to be one point there in truth. And let's do another couple of little tweaks. I'm going to select it, and I'm going to grip at it. I'm just going to come up here into this corner. I'm going to just grab that grip, and I'm just going to come to the inside just a wee bit. And I'll do the same thing. I'll zoom down to this corner, maybe click there, and then zoom or scooch out to the outside just a wee bit. Okay. And I'll leave these other ones alone where they are. So I just tweaked a couple of little things there. And I'm going to also rotate this. So I'm going to leave it selected. I'm going to choose my modify rotate tool over here on the side, or right click the mouse and do it. And I'm just going to let it go around the center, and I'm just going to sort of put it at a slightly different rotation, let's say like that. And so here's the scenario of what we're doing. We know what our deed should look like over here, but we've got some points over here. Now this one went 1, 2, 3, 4, 5, 6, 7. So we're going to create some points around this figure. And we can do that a number of ways. You can go to the COGO menu and choose create points from entities, and it would just drop points at every one of those vertex locations. Excuse me. Excuse me. So that could be possible. Um, the other option would be to manually put some points out here. Regardless of how we do it, let's just say create points from entities, and let's change the symbol here from the plus mark. We'll change it to this little circle just for yucks. And this is a polyline, so we make sure polyline is selected, and we're going to skip any radius or midpoints and draw these new points. And when we do that, it says select the arc, or select the polyline. So there it is. And there now we have points drawn with no descriptions. And it starts with point 8 and goes around to point, let's see, 8, 9, 10, 11, 12, 13. But I want to renumber those just for some convenience sake. So I'm going to go to my points menu, choose my coordinate file utilities, and I'm going to come down here on the right-hand side and renumber points. It's the third up from the bottom on the right. So I'm going to renumber which range of points, 8 to 13. And I'm going to start that from 101. So I'm going to correspond my numbers with these numbers over here, and I'll say okay. All right, I'm also, while I'm here, I'm going to give a description for those points. And this range of points will be 101 through 108 or 9 or 10 or whatever it is. Let's just call it 1000. So anything after that is going to be this particular description. I'm just going to call it field points. So I'll apply that, updated 6 points, and I'll exit and exit. So now I've got 101, 102, 3, 4, 5, and 6 up here. And they're going to roughly correspond to 1, 2, 3, 4, 5, and 6. But I've also got this 0.7 that we know is the closing point, and it's just a wee bit past where 0.1 started. Okay. So this could represent, now remember, we pulled these corners in and out here on the ends, and we pulled that point back. So this could represent some points that we found out in the field, and we want to see how they help, identify that they're the right points and which ones to use. How are we going to resolve this deed based on our field observations? And so that's called deed correlation. So I'm going to go to my survey menu, and I'm going to use this deed tools pull right. And I'm going to come down here and say deed correlation. And so it needs to know a deed correlation file to process. We haven't made one yet, so we'll sit in the new, and we'll call this one deed correlation. And now I've got a little dialog box, and I got 2 columns in it, one for survey points, one for deed points. And so when I do this realignment, which points do I want to move into which other? So I want to move my deed points to my survey points, or do I want to move my survey points to where my deed points are? Your choice. So let's assume my survey points are on stake plane coordinates, and that's all great. So I want to make sure that I'm going deed to survey. Okay. So we need to add some points. So if I add a point up here, it's going to ask me for a survey point and a deed point. Well, I can pick it from the list. Here's 101, and here's 1. Okay. So I'm going to add that one. So I've got that first pair. I'm going to also add 101 to possibly could be 0.7, because that's one of my deed points, and we could see which one that might hold better or not. Say okay. So I'm going to go through now and just add the remainder here, and you can do that by add a polyline. You can just pick figures. You don't have to have points drawn in them. You can just add those, and it would put the vertices in there as well. So I'm going to add these individuals. I know what they are. I don't have to hit the list button. So I'm going to go 102 compared to 2. I'll add now 103 compared to 3. I'll add 104, compare that to 4. And let's add 105 compared to 5. We'll add 106, compared that to 6. And we already have 101 is compared to 7 as well. All right, so that's our list of points that we want to look at. Now, you can see you can have multiples. Like there, you've got 101 can look for 2 different deed points. Same thing, you might have a cluster of 5 or 6 points down in one corner. You're not sure which one might be the corner. So you could say, you could add those in there as well. In fact, let's do that. I'm going to save this, and I'm going to exit. And I'm going to come up here down to this corner here. My last point up there was to 101, went around to 106. So I'm going to have up here, starting with 107, I'm just going to drop some points. I'm going to go to points menu, draw locate, make sure my next starting point number is 107. And I'll switch to using this X as a point here. And I'm going to just screen pick. And so I'm going to put one right in here. Just take zeros in elevation. And again, I'll call that FLD just for field point. You, of course, would put whether it's an iron pin found or something like that. So now I've got a 107. Out here's maybe a 108. So I'll take that, let it increment. So I'm just going to spray a bunch of points in here. Maybe get one even tighter. All right, so I got a whole bunch of points around here all the way up through, so 107, 108, 109, and 110. So now back to I finished that command by hitting enter. Back to survey, deed tools, deed correlation. I open up my file, and I'm going to add those remaining points. So they're all going to look for my deed point 3 I need to compare to. So I'm going to add 107 to 3. I'm going to add 108 to 3. I'm going to add 109 to 3. And finally, 110 to 3. Okay, so now I can save that. So now what I'm looking at, or what I'm going to be doing, I'm going to exit so I can just resume here. What I'm trying to do is to use these found points and bring my deed into correlation with my found points. And this is going to help me decide, because really we don't have this figure drawn. We just got some points here in the field, but we suspect they may be these corners. So let's see about getting that to happen, how we do that, and that's through that deed correlation. So survey, deed tools, deed correlation. Open up our file. Here it is. And you can see the correspondences that we are suspecting. And so there's a couple of there's some tools down here that are going to help us do that. So there's an inverse report. And when you choose that, that's just a straight off inversing. You got the survey points on the one side, the deep points on the other. And you see from 105 to 104, that 200, there's 200, 188, 898. So that 105 to 4 to 3. So these are all, there's 101 to 2. So they're going to, no, they're not exactly the same. There's a 214,738, 214,739, 814 versus 818, so they're close. But that just gives you a point to point between all of these, starting at point 106, looking at all the other survey points, going to 105, all the other survey points, 104, all the other survey points, all the way down the line, 103, 102, 101, 101 again, 107, 108, 109, and 110. And again, it compares over here at deed points. So 106 was looking at 6, 105 was looking at 5. It shows you those comparisons of point to point. So if we look down here in these secondaries that we did 107 to 3, 108 to 3, you would look for, let's say there's a 237,405, there's a 239,814. So it's probably not that point, it's a little bit far off, but you get an idea. It gives you a sense of helping you try to identify what might be the proper field point to hold as our survey point. Okay, so that's a report. Now, there's also this compare before align tool, and that just does an individual match basically from 106 to 6, 105 to 5, and that's basically an inverse between each of those paired points. Now, the distances and bearings along those, between those points don't really tell us much, but they don't tell us much in and of themselves. 106 to 6, we don't care. But if we look at 101 to 7, 101 to 1, or 107 to 3, we got 103 to 3, 107 to 3, 108 to 3, 109 to 3, and 110 to 3. We can compare those. So there's that one at 508, 174, and this one's 505, and this one's 506. So you can compare those kind of distances to similar values up here as well. That's just looking at that, again, straight point to point type of inverse. So now let's look at the check alignment button next. And what you're going to do is you're going to check a suspected choice that you might have. And let's say we suspect, and these are from the deed points, that let's hold point number 1, and we'll set the rotation from 1 to 3. And we say okay to that. And so now it says, all right, if you hold point 1 and your rotation direction to 3, you would have to translate your points by this amount in the X and the Y, set up this amount of rotation. And these are the residuals or the deltas for all of these pair matchings. Okay, so you want to look at those. Obviously, you want the smallest ones. And I've got some down here like 2.5, 1.5, 1.5, almost 1. So those are probably not the ones that we're going to use because we have a much better fit here with 103 as a 3/1000 instead of 2.5 feet of missing. Okay. So again, just another check. Now you've got a next button now that says to find the minimum alignment. Now this is going to be, now you can do this check alignment multiple ways. Let's say we want to hold 0.2 and set the rotation to 0.5. So it'll just do that same type of thing, and you're going to get these other high values down here that you know you probably wouldn't use. So these numbers, and you could do that for each one individually and come up with what might be the best point to hold and rotation to hold. But if you say find minimum alignment, it's going to go through and tell you that if you hold point 1 and set your rotation into 0.5, so you're going to hold your pivot point 101 and 1 and rotate to 105 and 5, and that's going to give us an average residual distance. We got that average distance of 1143, but those are not going to be the ones we want, but that still found our minimum differentiation between those points. So we need to hold point 1 and rotate into 0.5. And so then once you've found that, you can apply this alignment. So here's the point you're going to use. Let's say we're going to do this set right here. That's our, remember, we're bringing deed points over into our field locations. So we're going to do 6 to 2 backwards, 6, 5, 4, 3, 2, and then 7, and then 1. So all those points, you could just, at this point, I'm going to type 1 to 6, okay? Because I don't care about 7. That was the ending point, and we're going to try to adjust that. So there's really, we know there's 1 point there. So I'm going to take those 6 points, and here's my hold, 1 and corresponding to 101. And I'm going to set the rotation from 5. So the resulting rotation of 1 to 5 is going to match 101 to 105. So that's going to be good to go there. So now those extra points, like that point number 3, would not, you know, it knows to use 103 that's up here based on this, because I'm only moving these points around, and it's going to make that as our rotation. And so now we're going to do that, and we're going to come down here at the bottom, and we're going to say we want to align the screen entities. That's these drawn deed lines. We're going to ignore any elevations. We don't have any. And so we're going to say, okay. And now it says select the objects to align, but very, very important here. It says points excluded. So you can't just draw a window around this. We want to select just the line work because we're already moving the points. We said that up above. We said move points 1 to 6. So if you said it's going to move point 1 to 6, if you gathered up these points in this to align, it's going to move them this amount and then move the points again. It would just move them twice and rotate them twice. So make sure you do not include the points. You're just going to grab anything drawn in the screen. So you might have drawn a driveway and a house and, you know, everything else that goes with the property based on that deed, and you want to bring it all into the field. So you would select the drawn elements. Now I'm not getting the text because it should update for me because I have my linking on. So there's my line. I'll hit enter to finish, and it brings the line over. It says it aligns 6 points. Now they haven't moved yet until you say okay. They moved. 7 stayed where it was. What do I have over here? I've got 106 and 6. And 5 is down there. Now, why are they out of whack? Because of these other points here. Okay. So let's do this then. If we suspect, I'm going to undo that. Yes, I'll update. Yes to all. All right, so now let's try that again with survey, deed tools, deed correlation. This time I need to remove, I forgot to remove these extra points. So I knew that these 107 through 110 weren't part of my point set that really went to that. So I'm going to now remove, 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 remove. There's now, I'll save that. I'll go back and now recheck my alignment. Let's just hold 0.1. We'll rotate to 2, see what that comes up with. There, the residuals look much nicer. I will find my, let's see, that was our check. I'm going to find my minimum alignment, and it says, all right, hold 0.5 and rotate into 4, and that gives you the minimum amount of moving. That's our best alignment. And then I can apply that. Again, I'll come back here and just say 1 to 6. And so holding 5, rotating to 4. I'll say, okay, select my polyline. Off it goes. And now all the points have gone up and moved to those new locations. And you can see there it is. And 0.1 is right there. And if I select that, I see I've got a 0.101. I've also got a 0.1. And if I look up here, I've got a 0.2 and I've got a 0.202. And it's exactly on that corner or close to it. And I come down here and I see, well, there's my 0.3. That was my deed point. And you see it on the polyline. And there's now that point, which was my 103. Same thing, you can see all the way around here. They've got everything's moved into place. If I select that point, you see it's centered there. So that now has shifted my deed points into where these field points were, and it has recomputed these, and we can compare our field against our deed. So that was originally north 25, 30, 45 east. It's now north 5706, 36 east, because remember we rotated it. The distance is 165.45. Distance checks out nicely. That distance nicely. This distance, exactly the same. Still got the same curve, same distance there. And then 4930 looks like the same. So that's set up, and those little tweaks that we did up there were not enough to shift the distance in our calls. But that now has brought this, and this feature now, remember, has this overlapping point. So I could, and again, it's just a drawn polyline. So I'm going to go from there to there to change that, to coincide that. And I could even tell it that it is closed. Yes, it is. It's a closed figure. And then we can go to our annotate or our area menu. Let's say area by closed polyline. And we'll just take this. There's our area, etc. And lot 1. And we'll pick a point right there. And that gives us here square feet in our acreage. And that's how our deed correlation is going to work. Now, what happened when we did that? In our deed correlation, we determined some pairs that we wanted to check out. We checked out these different alignments with different tools, and we told it to find the minimum alignment. It found us that, and then we said to apply that. Now, here's what really happens in the survey practice is that you don't always do that to whatever this numerically comes up with. That's just a nice means of helping us mathematically find what would be the best geometric fit. What you really do as a surveyor, all you surveyors will know, you have to look at evidence. You have to look at seniority rights. You have to look at, the preponderance of this evidence and the condition of the points that you find. So there's all kinds of other things that really control where those corners are going to go, but that at least gives you a tool to find something mathematically or geometrically that will help bring all of these things into alignment with what we found out in the field. Okay? Questions on any of that? Very good. All right, so let's go back to back to our manual here. And let's do a little bit of coordinate geometry, which is something we typically do. And we're going to, because I got a typo there. So we'll look at some cog tools. That should have been Kogo tools. So we're going to uh, use we've got a coordinate file points here. So we'll make a new drawing and we're going to set an existing coordinate file to that. We're going to draw the points in here and then we're going to do some inversing. If you run on AutoCAD, see the, okay, there we go. And try some several results, do some traverse side shot, and then we'll look at the visual Kogo and see how they work as well. And that'll be a little exercise to run through. So let's close our file here. You can save it or not. We'll just make a new file of our choice. I'm going to get into my folder, and we'll just call it Kogo. And we'll say next. And when it asks for a coordinate file, we're going to hit set, and we're going to choose an existing file. There's my Kogo coordinates. I've got 4 points in there. Hit open. I'll say next. And it's going to come back and give us basically nothing. We're done. Nothing's happened other than we've associated that file. So let's draw the points. Let's go to draw, or points menu, draw locate, and let's just draw all. And there they are. There's 1, 2, 3, and 4. So remember now we had that option to turn our raw file on and off and turn our line drawing on and off. And the line drawing will automatically draw between traverse commands, not for side shot commands. But here's our commands in Kogo. They're right up here and you can choose them from the menu, or you could type those particular characteristics or those particular abbreviations off to the right, and that also triggers that command. Okay, so one way, let's set up an occupy point. Let's occupy point 2 and backslash point 1. So of those commands, OP was occupy point. If I choose that, it says set the occupy point, pick a point or point number. I'm going to say 2. So that's now my occupied point. And now set the backslash method. It's going to be by point. That's in angle brackets anyway. So I just hit enter and I'll pick a point and that's going to be 1. I hit enter. Okay, now if you have set, and I saw it flash over here, but it went away because mine's not set. I'm going to go back up to settings, Carlson configure survey settings. Okay, show occupy and backside on the status bar. Okay, so it should be set, and I should now see down here, and I saw it flash, but it went away. Yeah, I don't have it there to set, but it should show you down below. So if I'm in the middle of a Kogo command now, you'll see it. So I'm sitting at 2, looking at 1, and let's set a point from, I'm looking at 2, looking at 1, and we'll set that. So I'm going to say, let's do a side shot, which I think is SS. Yep, side shot. So it already knows. And now you can see over on the status bar on the far right, down here, it's saying occupied point 2 backslash point 1. All right, so, and that's in the AutoCAD version. The IntelliCAD version, I do not believe does that correctly. So you would just have to know where you were. Or if you forget where you are, you can just come back and do a real quick inverse. And if you wanted to set that same pair up, you would do an inverse 1 to 2. And that's just as if you traversed from 1, looking at wherever, and you moved up to point 2, it now looks back at point 1 because that's where you just left. That's what inverse will do for you very quickly, is to set those occupied and backside points. All right, so now we're sitting at 2, looking at 1. And we're side shotting. So let's enter an angle right. Now that's our preset angle code. We've got some options. If I type O, You can change that to prompt. So maybe you've got a bearing or an azimuth that you want to use. But right now they're a preset as an angle to the right. So let's just go something recognizable, 90 degrees. Okay, so it shows me a little temporary line. And I was going to set a distance over here. And you can get a sense as you move this cursor around. If you look down here in the coordinates, you're seeing distances and angles. Okay, so there's like 60. Let's set that up to say 100 as a distance. So 100 feet. So it points to where it would be. Once an elevation, we'll leave elevations out of the picture, and we'll call this one just SS for side shot. There it is, and it says, oh, well, wait a minute, we've got a point already used for point 1. I don't know why I must have misset the point number. So let's call that 101 and renumber it. All right, so there's now 101 computed by that 2 looking at 1. We're still in side shot mode. So this time let's do 180. And let's set another point 100 feet away. And no elevation. Side shot is the description 102. So now you see how that's computing. All right, so now let's change our setup. So I'm going to hit enter to finish. Well, press escape apparently. And I'm going to now sit on 3 and backside. Well, let's sit on 3 and backside 2. So to set that, I can either do OP and backside point another, or I can just very quickly, I want to inverse from 2 up to 3. That now has set. And if you look on the far right of the status bar, it says my occupied point is 3 and my backside point is 2. And let's traverse. So I'm going to traverse. And this time I'm going to go angle right. Let's go 90 degrees and go 100 feet. And we'll call that TRAV. No elevation. And TRAV. Let's get that part right finally. Okay. And now let's traverse again. Now, if you notice over on the status bar, it says my occupied point's 103. My backside is 0.3 because I've traversed. So I'm still in traverse mode. Let's go angle to the right again of 90 degrees. Let's go 50 feet this time. No elevation, also a traverse point. And then you could go into side shot mode. And we're now sitting here, looking back here. Let's go 90 to the right, 50 feet. And that's no elevation and a side shot. All right, so now we've let's see, 104, looked at 103, and then turn 90. Yeah, so there we go. All right, so we're through with that. We'll type E to exit. Now, what have we accomplished this work here? And if we turned on, remember, our raw file, I think I turned it on. I guess I did not. Yeah, I didn't. If I had turned on that raw file, which I'm sorry I didn't do it, let's turn it on. So that's why sometimes you want that automatically on, so it forces you to capture it. But if you do turn that on, I'll go to Kogo and turn my raw file on this time. We'll make a new raw file and call it Kogo. And we'll do a few more connections. So I'm going to inverse 1 to 2. So there's now my setup. And now I'm going to do some side shots. So I'll go side shot. I'm sitting at 2, looking at 1. I think I didn't see that. Let me try that again. Inverse 1 to 2. There we go. Now I can do a side shot. And this time I'm going to do, instead of 90, let's do 135. And let's go 75 feet. And no elevation. That's again a side shot. And we're also going to do, let's do a 180. And this time we'll go 200 feet. And that's a side shot. And now let's traverse. We're sitting at 2, looking at 1 still. We're going to go to the right to 215 as an angle. And we're going to go distance of 200 feet. No elevation, trabs. And now I'm sitting at that point looking at the other. Oh, looks like I did it, 2 to 215, or the distance of, say, 200 feet. No elevation, again, trab. And at this stage, we're going to switch to side shot mode. And I'm going to go 90 right. I'll go 50. No elevation, side shot. I'll do another one at 180. At 50. No elevation, side shot. And let's do one more, 270 at 50 feet, side shot. No elevation. Oops, I missed something. There it is. And then side shot. Okay. And now E to exit that. Okay, now what do I have? A bunch of points I did by Kogo based on those original 4 points, 1, 2, 3, 4. And because I turned on my raw file, I can go to survey and say, edit process raw data, open that file. There's my Kogo file. And you see it's captured all of the controls that I did when I first set it. So I've set up my backlight record of 2 to 1. Apparently it did take the first time. I did it a second time, so it did it. And then I set side shots for 106 and 7. There you see 6 and 7. And 8 was a traverse shot. 9, 10, 11, 12 is side shots. And so let's say this point where I traversed and I set up here to 108. Well, let's suppose that 108 angle, instead of being 250, should have been, see, where am I doing? I'm setting this point. So instead of that angle of 215, let's say that angle was, say 245. So you see how that's going to spread 108, and all of the points that come after 108, a different set of angles, and it's going to show up in my adjusted coordinates when I do it. So now I've recomputed these based on that raw file change that I made here. So let's say, all right, so I fixed the problem that I had. I'll just exit and I'm going to say, yes, save changes to the raw file. But nothing's happened to my points. So that was 0.108. If I double click that, see, it comes up right where it was before. But if you go back to survey, edit process raw file, open that file again, Kogo. That 108 is different from this 108, but we haven't told the coordinate file that this is different yet. And we have to do that. And we can do that by on our tools menu, you could update the raw file from the points so it would set that back. Okay, but we're going to come to file. Let's see, where do I want to change my coordinates. I think I'm going to have to process this first. So I'm going to go to my process menu, and I'm just going to choose no adjust. It's just going to compute as they go around. I'll say okay. So starting at 2, going to wherever it goes. Here's the changes and the reports and any kind of closure. I don't have any tie-ins with closures. So I'll say, okay, so now I've changed the coordinate location. And so what I want to do now is save the coordinate file. So I pull down the file menu, save the coordinate file, I'll save the raw file, and then I'll exit. So now, if I look at 108, it says, warning, the screen point differs from the CRD location by 103 some odd feet, okay? So which one do I want to use? Well, I'm just gonna press escape. I'm just showing you that it still hasn't updated that, but it does know that they're different now because I saved the coordinates. So how do we get these back into sync? Again, back on the points menu, coordinate file utilities, and down toward the bottom of the left, we're going to update the drawing from the coordinate file. If I do that, take everything, say okay, it updated 16 points, and when we say exit, you saw those points that shift up to their new position. And it was all of the figures from 108 onward. 108 used to be down here, it now gets swung around, and then all of these points that were constrained from 108, it pulled them with it. Okay, so that raw file processing can be your friend. It can help you. Let's say if you just mistype a number, so you don't have to go back and recompute all of those coordinate values. Okay. Now, a couple of other tools that you can do under COGO is you have this visual COGO. And if you do that, let's choose an occupied point. You're going to get this little dockable control or docked control over here. And when you get all of these, there's your occupied point, there's your enter and assign a point elevation or point coordinates, there's inverse, traverse, side shot, distance, intersection, bearing, distance. You get all of these different types of controls that you can use. So right now you can set the point. So I'm going to, and you see over in the graphics, there's a little picture of an instrument sitting on point 3. I'm backsliding point 2. Well, let's say I want to backslide point 1 instead. You can just type 1. You can pick it from the list of 1, or you can pick it from the screen with that button here. I'm going to come over there and pick point 1, and it says PP because I think what happened was I snapped to the end of that control. So I'm going to pick that. Now it identifies it as a point. When it says PP, that means picked point. And so I saw that and recognized that it was not exactly on point 1. All right, so there's now my setup. And so what do I want to do at this stage? So let's do some side shots, and let's go back out here to our point 3, which is right in there. And we're looking at 1. So let's just do a couple of side shots. So we'll go side shot to point 113. Now I'm looking at 3 to 1. So that would be, where am I? Can't see my point numbers. There's 3. All right, so occupied 3, moved it back to 2. So 3 to 1 is my occupied. And I hit accept. It now takes that. Now I do a side shot. And I'm going to go 270 angle right, 270. Notice you've got here the choice to pull down your choice of angle. You got a little calculator that can help you figure out what angles are based by particular points, all kinds of different little helpers there. I'll leave my vertical angles out of the distance, slope distance, which will be the same as my horizontal distance. And let's just go, see, we're doing 270, and we'll go 50 feet just so we can recognize what it looks like. And we'll do that as a side shot. Again, you've got a code where you can pick from a code, and that was our last field codes that we used. That's our, remember, the 17, 18, and ground shots. So we're not using a code table correlated to this. We'll just type in side shot, create a point, draw a line if you want. We'll not draw the line. We'll preview where it's going to go. That's where it would be. We'll store, okay? Any of you that use a data collector out in the field, particularly if you use Carlson's data collector software, you recognize that as a command, you're setting that up. So that was one side shot. Let's do another side shot. And instead of 270, let's just go around by 5 degrees and we'll just hit store. Let's do another one by 5 more degrees, 280. hit store. And now you can see right over here, I'm getting all those points. They're just 5 degrees apart as my side shots. Let's now traverse. Again, still sitting at 3, looking at 1. I'm going to go 270. And this time 100 feet. And I will draw the line. And you can preview it, you can store. And there it is. So I drew my line. There, went through there as well. Now, let's suppose I need to put another point at a bearing intersection of this line and these 2 points out here. So wherever those would indicate at that intersection, that's my bearing intersection. So I'm now sitting up here. It tells me my occupied point is 116. I'm backsighting 3. So I want to do a bearing intersection. And so I'm going to put in that bearing intersection. So it's going to go from the bearing of 3 to 116. Just, let's see, 3. No, I'm sorry, not this 116 yet. I'm going to go from point number 3. The angle I'm going to use, the bearing, I'm going to choose the calculator and I'm going to set that by points. And that's going to be by, and I'm just going to pick them from the screen. So that's going to be that point 3 up to that point 116. So that sets the first bearing. And now I'm going to set my other point, which was these, let me turn there, these points right here, 109 to 112. So I'm going to say, all right, from 112 then is my next point. And the angle there is going to also be by points. And that's going to be from this point to this point. Say, okay, that set that. And now I can preview where that's going to go. That would be, you can see it projects that out, and then I can store that point. So that now is a side shot method with a bearing intersection. Now, let's suppose we have, we want to do a distance intersection this time. And this is where you're going to get a 2 possible solution. And now all of these tools in the visual are also available on that Kogo menu. You're just going to, basically keep track of the points and stuff by your, keep track of them in your head while you're working around here. So if I want to set, let's say I'm going to set from point 4, I want to set a point that is going to be a distance away from 116 and a distance away from 117. So wherever those 2 distances might intersect, and you can say I'm going to get 2 possible solutions. So let's go to a distance intersect, and I'm going to start with that point number 4. That's going to be where I'm going to sit. And I want to go, let me see if I can get this right. If I want to go a distance of, let's see, 150 feet, make sure I've got enough to make the intersection. And from point 2, which is this point up here, 117, and let's go 200 feet from that, and we'll preview. All right, so there's, whoops, let's preview that. And that computes there. Now it should also have computed here. Okay, it's not giving me that double. Try this. I don't think, no. Well, let's see, if I store that, that would put that point there. Let me exit this. That should have given me 2. There may be something in the visual that's not computing that correctly. Let's do the same thing. 4 to 117 on their COGO menu. So I'll pull down COGO. I'm going to locate at intersect. I'm going to do a distance intersect. All right, so pick a point or a point number. The first base point, that was 4. The distance was 150. The next point was 117, and the distance was 200. There we go. There's our 2-point solution. And you simply pick nearest whichever one you want, either this one or that one. Or you can type A or B. So I'm just going to pick up here, and it's now going to set that point. I give it the elevation and its description. So now I've got actually 2 points at those bearing intersections. Now, under visual COGO, there is a thing. If I do a distance intersect under visual, let's do that same thing where we had 4, when 150 to 117 at 200. Now that should double up right on the next, where that next point was. And when we say preview, that's only going to give you this one. Now, the reason why, and we won't set this point, but in visual COGO, when this does this, there's a rule that gets applied, is it takes the point you're starting from, and if you superimpose a little quadrant around that, it's going to find the first solution clockwise. Well, no, see, I should still find this one first. There's something about it. Let's take a look at the help system. Visual COGO. And let's turn our search highlight off. So visual COGO, now there is a thing here. Bearing distance. Distance is at 2 base points along with distance for each distance near the same point. Oh, here it goes. For the 2 possible solutions of this distance intersection, the intersection clockwise from the first point is used. The dialog has fields for the output, point number, description. Well, that still should have found that one, because if I look straight up, this one is over here. So that should have been clockwise from there. Although I think when it says clockwise from, it means a line to the east, which is the 0-degree mark in the CAD system. So starting on that azimuth, as you swing around it clockwise, it finds that intersection first. So visual COGO won't give you that double, and the regular COGO will show you those 2 points as to where they're going to be. So if I wanted to set this point at those particular ones with visual COGO, I need to swap the points, right? So I would go back to COGO, visual COGO. Let's do a distance. And this time I'm going to start at 117 and go to 200. And then 4 at 150. And I preview that and see that. Now it finds that one, because if you extend that east line and go clockwise, it hits that before it hits this. So that's the way you handle those double solutions in visual, is you have to, if it's not the one you want, just reverse the point pairings and point and distance pairings, and then it will find that next one for you. Otherwise, when you do it from the pull down or from the command line, it's going to actually show you where that happens to be. Okay. Any particular questions that may have occurred with any of that? Anybody do a lot of COGO work as we set our points and we calculate things? And I can give you an example. I had a friend, he's passed away now. He actually owned a surveying company here in Pittsburgh and was one of the founding fathers of the industry here in this area. In fact, worked with Governor Thornburg to write the state registration law for surveyors. But ask somebody to draw a square in a drawing, and people would, click a point and they would, set an angle and a distance or whatever, or they would just simply draw a rectangle from click to click and draw a square like that. But not Howard. He was so Kogo oriented that he would have a point that he wanted to start with. He'd drop a point there, and then he would start locating points by traverse, and he would traverse his way around a figure that he wanted to draw, whether it's a square, a rectangle, or some kind of, varying distance type of thing. But even with simple geometric figures, he thought in Kogo terms much more quickly than he could in graphic terms of just drawing things in the drawing. And there's nothing wrong with that, because when you're done doing it either way, you still have a polyline or a line or whatever you're drawing. So either way is perfectly correct. But he does that, he did that all the time, and he would create all these little Carlson points to help him draw figures. And that's perfectly legitimate, perfectly fine to do. And like if you were said, draw a square between 111 and 119 and whatever else it needs to make coming out here, I would probably do it by, draw a 2D polyline. I would go from that point to that point. Now, where am I going to go with that to make it a square? Well, I'm going to go in this direction somewhere, and it's probably going to wind up at that point, but I don't know for sure. So what I would do is I would leave that like that, and I would do that four-sided building. I'm going to survey and do four-sided building, and it wants to know the line or polyline. So there's the line, and it wants to know an offset. Well, I need to know that distance to know that offset. So first thing I would do then, instead of doing that one, is I'm going to do a quick inverse from 111 to 109, see what my distance is, and that's a 50-foot distance. Okay, so I would then um, escape that, go back to my four-sided building, and I would put in this line, and I would say it's 50 feet offset, and I would pick the side, and there it is. So yeah, it does go through that same point because that was calculated as 50 feet. So that's, the way I might approach that if I had to do a square. Or you would even do something like this. You need to draw a square between 111 and 109. So I might be tempted to just simply draw a rectangle. I'm going to do this. I'll just draw a, Carlson didn't have a draw a rectangle tool. I'm going to draw a rectangle. I'm just go from here up to here. Okay. Now, I know that I need to put that, lined up with 111 and 109. So now let's see, I haven't made this a square. Let me make that a square. All right, so if I draw a rectangle, I'm just going to draw a rectangle, and I'll pick a point, and now the other point, I'm going to set it as equal distances away. So I'm going to say the at sign, just like in an email address, meaning relative to the last point, and let's just call it 25, comma 25, meaning go 25x and 25y, and there now is a square, but it needs to be 111 to 119 around this way. So I could go to edit, align, just a standard 2D align. This time I'm going to align this object, and it says, all right, pick a point or a point number. But it says, what's the first source point? Well, that's this endpoint. Now, what's the first destination point? Again, look at that line above. So the first destination point is 111. So that's setting that, and it wants to know now the second source point, which is that endpoint, and the second destination point is 109. And enter, and that sets that. And it asks me if I want to scale the objects based on that. And if you do, which we do, we'll say yes. So it moves it into that alignment and scales it based on the amount of difference that it has to bring that edge up. If we said no, the same 25-25 would be right there. Okay. So any of those methods are perfectly valid to set the point. You could have known that 112 was 50 from 109 and 111 was 50 from 109. You could have drawn that two legs of a four-sided building and then done four-sided building. It would compute back to there. You could have gone and done you could have located this point based on a bearing or based on a distance intersection from 111 to go 50 feet, 112 to go 50 feet. It would drop a point out here, and then you could draw squares between the points. So any of those methods are perfectly valid and fine for us to use to set that, to create that figure. Okay. So now what we're going to do is we're going to take our mid-afternoon break and we'll get our full 15 minutes in this time, I promise you. And when we come back, we're going to take a look next at this LotNet processing, where we talk about this automatic um, subdivision creation. And then that will be a way to wind up what we're looking at. We'll look at any questions that we might have. But you can see, it can do every bit of all this, set all your setback lines, place, excuse me, place all your place all your building pads, set their elevations. It can even set the elevations of the lot lines and the road edges and everything based on the road profiles and certain slope limits that you're going to give to it. And it can grade this entire subdivision based on where the road grades are, set the pad elevations, everything, do all of that, all based on a set of rules that we give it. Okay. So being 21 after, let's take our 15-minute break. We'll come back at 36 after. Unless there's any questions that you might have popped up right now, we'll take any of those. Everybody good? Okay. So I will stop our share and I will pause the recording. You'll be happy to know I remembered. All right. So we're going to spend the rest of our last hour here looking at LotNet processing, which what LotNet does is it basically automates a lot of the layout tools that you have individually where you can define lots, piecemeal, or maybe just a little section of something. You can do some of those lots individually. But this is going to tie it all together in a single interface. This works very similar to the way RoadNet processing works in civil, if you've ever seen that as well. It takes all of these things and puts them together and recognizes interdependencies of them all and sets the other entities that it's going to generate based on certain rules that we give it. So we're going to open up a drawing file called Clearwater Oaks, and we'll make a new coordinate file for it. And that file has been pre-drawn with a closed boundary of the subdivision and some interior roadway center lines. And those are the two things that we have to have LotNet work. We need a closed exterior boundary, and we need centerline files for the roadway. And if they are intended to come from outside the subdivision, of course, they have to start on that edge of that subdivision. So let's get that started. We'll open up Clearwater Oaks. So I'm going to close this file, our Kogo file. And let's open, we'll look in our folder, which I think I'm in. Yep, so data sets. And we're looking for Clearwater Oaks, and it looks like that. Okay, so everybody should have this. I've got a closed boundary here on a layer called boundary, oddly enough. And then I have three center lines on a layer called CL-Pro, so proposed center lines. So I've got a main roadway that comes in off here. We'll put a cul-de-sac at this end, and then we've got these connecting roads with intersections. And what we want to get to, where we're headed, is something like this. We want to define the rules so that we get our lot layouts accordingly. Let me see what that area was. Looks like we had 10,000 square feet as about a quarter-acre lot. Okay. So to do our LotNet processing, LotNet is, again, on our area layout tools. This is where we do our layouts, and you've got some different individual things. I can do individual lot layouts. You can do parking lot layouts, some different rules there. You can adjust areas like sliding side, hinged side, so you can adjust a parcel to be a particular given area. And then you've got these different things here under LotNet. You've got some settings, you set the boundary, you do all these different things from this whole section of the menu right in here. And then there's some more individual lot, individual lot tools to set lots based on certain things. Again, by uh, just on a piecemeal basis, but LotNet is going to work here to our advantage. Now, one thing I would recommend, instead of pulling all this stuff from the menus all the time, we've got two very nice Carlson toolbars, and it's down here under LotNet, if I can find it. Here's Lot Network. So this is going to be the basic set of tools that we're going to use. That's going to set our settings, set the boundary, set our road network, and do all of the different things that we're going to use. And it has these adjustment tools and everything built into this toolbar. So if you pull that toolbar out, again, it's under Carlson and it's under Lot Network. I don't think this Lot Files tool has much in it to offer. Let's see what that looks like. This is the Lot Files toolbar. Let me pull these guys back. This is where you can do that. You can design a lot by clothesline workout. These are those individual tools, so we don't really need that. I'll leave this floating out here. We can take a look at that in a minute. All right, so what we have is this lot or subdivision that we're going to call Clearwater Oaks. And let's establish a couple of things in the order. We're just going to follow down our toolbar here. We're going to first choose our settings. We need to set up our settings. So we click that. And this is going to first ask us to choose a lot network file that we want to use. And that file, we'll just keep the name. I'm going to make it a new file. It's called Clearwater Oaks. It suggests the same name as the drawing. That's fine. We'll take it as okay. And now we need to fill out a couple of these questions here. So right now the road network says none, and we need to assign a road network. We'll come back to that in a minute because that would be if we had one already made. We do not. We could make it new, but we'll do that as a second step here. You can start your lot numbering. Let's start with 101, for instance. Maybe we're in the 100 block. And let's see, your starting block would be, let's call it block. We'll do block 1, lot 101. That'll be fine. And we want to give certain tolerances to our lot area. In this particular case, we're going to say, within 0.004 as a tolerance. So it calculates that, and it gets a little bit of grace on calculating those numbers there. The edge direction is going to be either toward the frontage or away from the frontage. And when it talks about an edge direction, it's a lot edge. So we're going to take it from the frontage of the road away from that frontage back to the back parts or the interior parts of our subdivision. And let's see, a lot closure tolerance 0.001 should be fine. You can create a lot file. So I'm going to output that lot file and I'm going to choose the select button. And I'm just going to say new, and we'll call it CW Oaks, just as a separate little name. And you can draw points, so it can draw points around all. We won't do that at this stage. A coordinate file, let's select and give it a new coordinate file. And let's call that one also CW-Oaks. So any points that we generate will go into that. You set the layer for the lot lines. So it's going to be a layer called lot edge. And now building placement settings. So if you have a file, right now it's just set to the default. If you edit those values, then this can place buildings on our lots. So right now we're going to say we have a 20-foot front setback, we have 10-foot side setbacks, and a 10-foot rear setbacks. Or you can find customs, set your layers. You want to draw the setback, and it's going to go on that lot setback layer. Building pads, the buildable polyline layers, etc. You can draw the building pads and you can put them on a layer. You can rotate those building pads based on their orientation toward the frontage of the lot, so it faces the street. You can draw building symbols and all that kind of stuff. A building pad width can be 30 feet by 30 feet, so that's a 30 by 30 little unit. You know, they can be whatever you wanted. Let's say it's 30. Let's make these say 40 by 25. So they'll be rectangular looking. Building pad name. Now the setback here is a setback away from where we've got buildable setbacks going up to our setback line, and our front setback was 20 feet. So we'll make sure that's 20 feet as well. You can draw driveways, all kinds of things, driveway left and right offsets. Setback at our 10 foot. And let's make this, let's say 6 feet for both setbacks left and right. So 12-foot drives. We won't do any setbacks there. They'll come straight off the road there. Connection, you can take straight or curves, or you can flare them. Let's do curves, see how that helps us out. So the fillet on those, let's make a 10-foot fillet distance. So 10 feet back, it'll be a 10-foot radius curve. Any additional building pads, etc., we'll set there. So we'll leave those. We'll say OK. Now we're going to label our lines and arcs, label the areas. We'll just take the defaults for now. I'm not going to hatch anything. Any additional lot types, I think everything's good for that. We'll say OK. So we've now set a bunch of settings, and we're going to edit those as we go along and reprocess. And so that was their first button. Their next button is to set the boundary. So I'm going to choose that, and I'm going to pick that outside boundary. There it is. I hit enter to finish. That's now established, and now it says the road network. So I need to create, oops, I need to click that, and it's going to ask me for a file. Again, I'm going to come over here and under new, and I'm going to call this one also CW-Oaks. And that's going to govern the network of roads. And so it immediately goes into the road net processing. And we've got roads, intersections, sidewalk crossings, and cul-de-sacs that get identified. Right now, we haven't told it any of the alignments yet, which we will. And let's look at the settings first, our little gear icon. And we want to look at our display options. We're going to say highlight a current center line that we choose. We'll just say thicken that, and we'll put a target around these intersections. Now on the process options, we've got road transition default. So anytime a road hits another road, we're going to put a 25-foot radius on those edges. And to process on updated design files, if we change the alignments, we want it to automatically change the entire road layout and pick that up, or have it prompt us telling us that you've made a change, do you want to reprocess at this point, yes or no? So I'll leave it to prompt. Right away, snapping, 5-foot tolerance. I'm not sure exactly what that would create for us. And then the output options is to create lots. And again, you've got a target lot area, your choice of square footage or acreage. So let's target a 10,000 square foot lot with a minimum frontage of 50 feet. And we're going to compute that 50-foot frontage either from the road or from the setback. So let's just do it from let it go from the actual right of way. And so we want a minimum lot depth. So how far back do we want those lots to be? So they're 50 feet across the front. We'll make it a minimum depth of 50 feet as well. A maximum depth, let's go 200 feet. So you're going to get some corners that are going to go to a certain distance. And a minimum back distance, which would also in these areas, that's going to be, it has to compute to at least a minimum of a 50-foot back. And then interior or back reduction offsets. I'm not sure. Reduce offset. I'm not sure exactly what that particular one does. If we look that up, minimum depth, minimum back distance, the minimum distance along the back of the lot. Okay, so we can actually turn that down a little. They can make pie-shaped lots. The interior back reduce. For interior boundaries generated between lots, this reduces the number of boundary vertices. A vertex is removed if it doesn't affect the boundary by more than that particular amount. Similar to reduce vertices command. Okay, so this minimum back distance, let's set that down to 30. So it can make sort of pie, well, let's even make it smaller. Let's make it 10. So we'll at least have a 10-foot back line as a minimum. And the, where was this? The reduce method. This is if a vertex on a lot line is within a certain distance of being on the straight line that it would, if you take it out, that's going to give you a sort of a way to clean up your points. So I'm going to actually up that to be about half a foot instead of 0.1. So it can reduce the number of extra little points it creates. And then we'll start with lot number 1, block 1. My lot type is just my default, and check for building placement. And when you do that and set that up, it wants to check those values that we set in our building setups already. And then we'll say, okay. And now and that's where we just were, yeah. So we say okay to that. We've now set up our lot network, or road network rather. And so what we want to do next is within this road, we're going to establish our roads. We're going to add or take away. And we've got, different functions here, save as, that's our draw, that's our reports, and that is a erase and process. So the first thing to do is on roads, I want to add these roads in here. So I'm going to choose my add button. And it wants me to select a center line by a center line file. Now, I haven't turned these into center lines yet, have I? So I need to screen pick the polyline. So I'm going to screen pick this guy, and I will assign a centerline file to that polyline. And I'm going to call that one Clearwater Drive. That's my main drive through there. It's going to have a center line. I'm going to have some right-of-way offsets, and I'm going to make these 50-foot right-of-ways. So I'll make a new right-of-way file. I'll call that one again, CW-Oaks. And I'm going to edit that file. And I want my right-of-ways to be 25 feet either side. So that will be a 50-foot. I can have additional offsets if I want. That's good enough. Save that. It goes on that layer and exit. So I've established my right-of-ways and any other things like a template point center line that would be something that might modify the original alignment. I'm not going to have any there, so I'll say okay to that. I've now established that road, Clearwater Drive. I want to establish next this road up here, so I'm going to go and choose add again, and I'm going to add a road by screen pick polyline. I'll pick my polyline. I'll assign a file to it, and this is going to be called Oak Drive. And again, I've got the same right-of-way offsets. I'll keep that the same. I'll say, okay, I'm going to add one more road. And we'll say road, screen pick the polyline. There it is. We'll assign a centerline file to that. And that's now going to be Acorn Avenue. Clever names. And we'll say, okay. All right, so now I've got each of these are identified, but it is also now identified the intersections. There's my Clearwater Drive intersection. There's my Clearwater Drive and Acorn intersection, and there's my Oak Drive and Acorn intersection. Okay, let's do a cul-de-sac. So if I assign a cul-de-sac, we want to go to Clearwater Drive. That's our main one. We'll say okay, and let's put it either at the start or the end. So it's going to go at the end right here. And we want it to be just a standard cul-de-sac style, which is going to have those little return radii in it. And let's set our cul-de-sac right-of-way radius, which would be if we have a 60-foot pavement. So it's good. If I have a 60-foot radius for my cul-de-sac pavement, and then I'm going 25 feet. Let's see, I'm going to make my road edges. We're going to make two 12-foot lanes, so 24-foot roadway lane width. And that, let me see. Yeah, so then that gives me, if I'm 24 feet, no, if I'm 12 foot each side, then that gives me an additional 13 feet out to the right of way. So I want to go, my right of way radius is going to be 60 plus 13. I'm going to make that 73. And then my fillet radius, I'm just going to 25. And no offsets. I'm not going to come up here and kick it to one side. I'm just leave it straight on. And now my output file centerline output template ID. Let's leave that one alone for the moment. Let me see. I haven't set yet my pavement width. Let's see if I go up here and double click. I set my center line there, my right of way. So I'm not actually setting pavement width here. I'm just doing the layout for the properties. Okay, so excuse me. So now I'm gonna want this cul-de-sac to be by pavement. It will have a 60-foot radius, and then it's going to have that additional 13 foot of right of way. So if you do this and choose process, it's going to draw everything that it can based on those rules that we've had before. And there they go. And it looks like it's thinking here to set these last ones up. There, it's completing those, completing the labeling. And now it's drawn everything here. Now let's change. I'm going to exit my lot network for the moment. Yes, I'll save the changes. Give me an unhandled exception of whatever reason. Now, to help us identify a couple of things in here a little better, I've got, these are my driveways where it's tried to draw the driveways in. I didn't get them set correctly necessarily. Let's maybe take those out of our settings when we do it for the next time. But let's set some layer visibility. So I've got my right of way. I'm going to make them um, sort of this orangey looking color, maybe 40, 31. Where's 40? There's 40. And we'll make it, see if I've got a sort of right of way looking line here. I haven't loaded. Let's use a Phantom 2. So that, that makes our right of way lines look like that. And then let's do our setback. Lot setback, we'll make them sort of gray looking. And we'll give that a dashed 2 line style. So that's going to be our setbacks. Our lot edges, we'll make, let's make them green, keep them as they are. What else? We have the buildings. Let's make our buildings blue. Our drives, let's make yellow if we figure out how to set those driveways in better. And I think that should be enough that we can tell what is what. So we've got lot edges, we've got setbacks, we've got buildings, building footprints, driveways, right of way, the center line, and we've got all of this annotation around each of these lots. So you can see, obviously, a lot of these things are just jumbled in on top of each other, so we can set that up with their labeling defaults. So let's go back to our lot network settings, and where it says labeling, automatically label, update, lot edge, label the lines and arcs. Right now we've got the default, but let's edit that default. And this has to do with lines and arcs, how we want to draw them. So any kind of lines, right now down here it says line tables, use line tables. Let's say either never, always, or by scalar. Let's say by scalar. Now remember that's plotted inches, and I want to make that scalar. We'll start with that table 1, and here is the distance. So if it's going to be less than an inch in our map, we want to use a table. And you need to follow the prompt at the command line when it goes to relabel this, because it's going to stop and prompt you for a table location. So you'll need to give it that as well. So that's going to be our line tables. Our arcs will do the same thing. We'll use curve tables, again, by scalar, and we'll give that an inch. We'll do the same thing. We'll say okay. We'll say okay. And now, if we were to reprocess this, redraw all lot network labels. So we let it draw. Now, what's the prompt area when it gets to the place where it needs it? Pick a curve table position. So we'll put our curve tables right there. And now a line table position, we'll put it over here beside it. So that's going to be where it finds labels that won't fit and it puts them in the table. And you can see as it's calculating there, the progress bar will finish. All right, so that finished that up. And this is actually on a label text. Let's change that color. Make that white. And now we're back to where we've got curves and lines are identified here now, L52, L53. Now that's going to be with a style of standard. I may set that standard style. I've got another style here of bearing distance. So I'm going to set my standard style. Instead of that text, I'm going to use that Roman simplex. So that now looks like more consistent. And here's my lots. Now, you may notice, see here, it's trying to take this driveway off of this. It's basically stuck in an intersection here. So it comes from the middle of that to set this here. But it also made, a half-acre lot instead of these quarter-acre lots. Same thing here. It's coming from that intersection. So you can manually adjust those kinds of things, or you can even, in this case, so that's not quite 10,000, enough to get 10,000, because that would be 20,000 if I split that in half. Okay, so we can do some adjustments here. Down here's another place where it set that corner, but then it made this lot huge. So I might want to take this edge and bring it down to this corner here so that they're both kind of long uh, lines into this particular corner. So one of my choices up here in my toolbar is you can add a lot edge point, you can remove a point, you can move a lot edge point, and then subdivide your areas, sliding side, all that kind of stuff. So if I take this lot edge, I want to move that lot edge point. So I'm going to choose that command. I'm going to pick near that endpoint. Now pick a point on the polyline to edit. So that endpoint. Now where do I want to position it? I want to put it right there at that corner. So now there's going to be my new one, and I'm going to take that little bend out of that one as well. So, well, actually it's set to automatically reprocess. So it's going to reprocess that. So now to keep that little kink out of that line there, I'm going to come up here and say remove a lot edge point. I'll select the lot edge. I removed that point. and I'm now going to move that one back up. So if I move this point, I want to put it, first I want to unlock my parallel, and I want to go perpendicular to the arc, or actually, shoot, I meant to do to the right of way. So I'm going to edit this. I'm going to move this to be perpendicular to the right of way. So that now would be coming off of there. So that's done. I'll hit done, and it's now going to recalculate. So now I've got a couple of long lots, and maybe that can be a selling point, or let's come up here and work on this as a, let's subdivide this lot, and we're going to actually, let's see, if I scoot what I have, I've got a little bigger lot here, a little bigger, then I've got 10,000, 10,000. So I need to push this down a little further. If I pull this, if I get that corner down to that corner and reset that line, that'll make that a little smaller. I'll make these a little smaller. So we're going to adjust a couple of areas here. I'm going to move a lot edge. Let's first, I'm going to remove this lot edge here. So that would combine that into a single lot. And now I'm going to add a lot edge. Let's say I need to add it first. I need to draw it first. So I'm going to draw a 2D polyline. I'm going to put it on, let's see, I'm going to I'm going to put it on this layer. And I'm going to go from that corner, and I'm going to go perpendicular to my, that's actually right on a curve. Yeah, so let's go to that end point. So that's now been added. It's been drawn. And so if I want to add that lot edge, I now pick that line and hit enter. Select lot edge to add to. It's not a lot network edge. Let me see. Let me undo this bit. All right, so what I want to do is actually move that point. If I move yes, I should have, I should be able to draw. Say that endpoint. Let's go up to that point there. And that now should be a lot edge. So if I add that as a lot edge, select the lot edge to add to. All right, if I repeat that, select lot, so if I take that lot edge, pick or enter the point to add. That corner. Yeah, it's not doing that exactly the way I'm thinking it should. And let's just move that lot point. So if we take this lot edge, move that point to that point, and we'll take this and move that point up to that point so it's radial. Now we finish that and let it recompute. So let's move that down a little bit, made it a little more even. Let's set this lot down here to 10,000 square feet. So we're going to slide that. So let's choose a sliding side area. No line work errors found. Pick inside the lot to adjust here. Select the edge to adjust this edge. And I want to give it a target area. Right now, square feet is my default. So I'm going to say a 10,000. Hit enter. And it slides this down to where it is 10,000 square feet, but holding up here. So it slid down and it now is 10,000 square feet. I'm going to do the same thing to this one, make that one also 10,000 square feet. So if I do a sliding side, I'll pick inside of here. I'll pick this side, 10,000 square feet. Hit enter, it will recompute, come down here. Now I've got 10,000 square feet here. And now I'm going to do the same thing here for this one. So let's do a sliding side. Here's our lot. Here's the side slide. We're going to make 10,000. All right, so now that is given that. Now I can also look at this and I see that L2, L3, L4, that needs to be, the labels need to update, which we can have them do. We can also, bring these corners into agreement, things like that. But let's go up here and now subdivide this into a 10,000 square foot. So we're going to subdivide that area. So subdivide, here's the area to subdivide. And I want my target area to be 10,000, the minimum footage of 50. So similar type of thing. I'll say OK as the lot network. So I'll say OK. Now pick the end of the frontage to start the lot with. So I'm going to start down here and the end of and it goes up here. Now it's going to set that to 10,000 and this will be the leftover amount. So 11 is almost 12,000. So now it's adjusted that. It's given me that extra lot. I come here. Now I could do something like, if I think these are too big and too big like that, swing that edge down. There's all kinds of little tweaks that you can do. But for now, it's generated this as my subdivision. And if I look at this, I need to get these labels redrawn now. And the offsets, see that goes to there and then straight down to there. So these all need to be redrawn. So I need to go back now and update the labels, redraw all net labels, lot network report, and inspector. If I run the inspector, for instance, as I travel around, you can see there's the lots. It reads you the details about each individual lot. And so let's update the labels. Let's redraw the labels. looking for those L1, L2, L3s in there to go away since we've adjusted it. And we'll wait for the progress bar to finish up. Okay, so right in here, this L9, for instance, is that little piece right there, which doesn't really need to be there because this line should go from that corner to that corner, but this line goes from that corner to that corner. So there should be, and you see what's going on. This distance and bearing is taking this line. So this distance, L9, you would subtract from that total distance there, or add to rather, to get this distance up here. So, you got a few things you might need to tweak and adjust on that. There's my L6, L5, L10 down to that corner, L9 to that corner. So, and then those all populate over here in your line and curve table. Let's take a look at our settings and let's look at that driveway. Settings. Let's go to my lot net again and look at its settings. Report. There's each of my lots. I keep getting a little error condition coming up here. I want to set those driveways. Let me see. I'll put lot file. It's giving me that. There's my road network. Label the line, label the areas, label update, lot file, direction, direction. That's all well and good. The other settings, double click that. Create lots. Here's my settings. 10,000, 50 foot. There's my perpendicular right of way. Add to the, so any remainder, I choose to add to the last lot, or you can apply it equally to all lots, or you can create a lot on the back edge so it can tighten up those long lots and put a separate lot there. That's all still like I like it. Keep getting off of that. I want to set the driveways, draw the driveways. Those. in that building pad check, I believe. Create lots, it's that. Oh, there we go, settings. Great building placements, that fronts, that's a bet for the setbacks for the buildings. Seeing. Points, set that up. Like labels, lot line layer, building placement. Draw the setbacks to pads and the driveways. So here's where I've got those right and left offsets. Now those should be I want to see them as the width. I need a 12-foot driveway. So I'm offsetting left and right. If I make that 0, go to the right. And reprocess. I think they have those driveway offsets might not be coded correctly. That's a new feature. And see right here, another lot edge that you might want to, you know, fix a little differently in there. Instead of having it like that, you might extend this one up and let that one come back there. Yeah, see there now my driveway. I think they've got that. They've got the driveway offsets coded in. I guess it's right of the edge of the building. And so, and you could choose, of course, not to draw them. So, but that's generally how this would work. And I would take this and turn this into an arc, maybe. Or just simply get rid of that segment. So if I delete a polyline segment, that would look more like a driveway would look. So, you know, it got a little bit of cleanup around some sort of tight geometries. I would remove that segments as well. So it's not crossing on itself. You know, so you could go through and do that cleanup. Now it missed labeling in here, see. So I'll exit that, or my error, and then redraw the network labels. And you can see what happened down here is it took that lot and then subdivided it separately. So you might want to, you know, maybe make that a double lot, but take this little angle point out of it and split it down this direction. Same thing that we did the first time with this lot edge, we could swing that down and make those tweaks. So if you go back to this, and if you go back and reprocess that road network, it's going to reprocess the entire thing and try to recreate it from that. So once you get to this point, at that, at that initial stage, now you're going to go through and start cleaning things up, like that lot corner you want to put right on that property corner, maybe. Um, you can decide as to how you want those lots to look. But the key concept of all this is it does all this stuff for us automatically without us having to go through and try to figure out where to set these things independently. Okay. And there now is that finished subdivision. Again, you could make those edits on these lot lines. So you would take, um, actually maybe remove that lot line and have this one extend, swing down to that corner like we did before. Maybe straighten out this one to be a straight line between, so that it's, now that's 10,000 here, 12,000 there. So you've got a total of 22,800. So you could remove this lot line. So let's in fact do that. Let's remove the lot edge. We'll remove that edge and that edge. And so that's going to recompute that into a single lot. And then we're going to subdivide this, and we'll say subdivide that area now. This area will have a target of 10,000, but there's going to be a remainder. So you can either add it to the last lot, or let's just apply it equally to all lots. And we'll say, okay. And we'll say start on this line here for the frontage. And it's going to compute. So now that's 11 and 11. So they're equal area. Okay, now you could swing that a little more this direction if you'd like. But still, if you were to swing this down from this point, that's going to cut into that total distance. So this is actually the best placement for that line to give you that equal area across there. So we could do, it could still be, if we did this, let's take, we're going to move this corner. So let's move that lot point. We're going to move that point, and let's go to the midpoint here. Okay, now, when that recomputes, you're going to see the areas here change. But now that we've set the direction of the line, we can do a sliding side area and give this one that original, what we didn't write down what the half area was, like 11 something. But so we'll do a sliding side area. This is the lot will adjust. We're going to select that edge, and we're going to slide it to be, let's say, 11,000 square feet. It'll now scoot it. It's supposed to be sliding, not hinged. Or did I choose the wrong one? Let me see. Undo that. So that's now the sliding side, not the hinged side. So sliding side area. Let's pick this lot instead and take this edge. We'll give it 11,000 square feet. I want it to slide parallel to where it is, and it's not doing it for whatever reason. Oh, I know why. Because we told it to go perpendicular to the frontage. So it's coming off this frontage and forcing it into being perpendicular to that right there. So if I don't think we have control over that right now. I can simply move it to adjust it. In fact, let's do this. I'm going to undo that one more time. And instead of using this one from within the context of LotNet, let's do it from here. And these are not, yeah, not from this toolbar. We'll close that off. If we just do area layout, adjust areas, let's do a sliding side area. And we'll define the area by pointer, close polyline by line work. Select the segment to adjust, this one. Keep the existing polylines, no. Define the new line by selected line, another line, angle, or point. So let's do it by angle. And with the bearing is going to be 4, that's my northwest quad, 24.1107. And our target area is going to be 11,000 square feet. Let's see, down there to find the target area. So that may be why. If I do it, define area by points or close polyline by line work. Select the one to adjust there. Keep existing, no. Define the new line by selected line. Let's just choose the selected line. And let's go by 11,000. You can't find it. Oh, selected. Let's try 10,000. Well, that's why it's certainly you can go up enough to give you 11,000 square feet. If I draw, we'll draw a 2D polyline. I'm going to make this different so we can see it. And we're going to go from this corner to this corner to that corner to that corner and close. All right, so now I've got a figure and it has, if I select that and I look at its properties, I see it has an area. Choose that one. It's got an area of 7799.91 square feet, which is why it rounded up to 7,800. So 7999.91. Now I've got a means of doing an offset. Let's see if I can do this offset to area. It may take the whole thing though. If I pick a line or a polyline to offset, it was that one. The side to offset is going to go to the outside. Keep existing. Yeah, might as well. Create a close, yes. Enter target area. Let's say 11,000. So now if I select, oh, that's that amount. That's an area of 11,000. So that wasn't the best approach on that one. We can undo that a couple times. And still, the sliding side area still should work for that, but it's nailing it down to being perpendicular to that frontage line based on the subdivision rules. So I might have to do a little manual calculation in there to figure out what that would be. So if I take let me undo that. If I draw 2D polyline, again from here to here to here to here and close it. Now I'm going to take that polyline. Let's just move it over to here. Now, if I want to slide that line such that this will give me my area, I'm going to adjust my areas, a hinged area by line work, select it, select, oh, not, I'm sorry, not hinged area. Adjust my areas by sliding side. So I'll choose by line work. There's the segment I want. Keep existings, let's say, sure. And now define the new line by the selected line. In other words, I would say choose the selected line and let's choose a target of 11,000. I think I suspect why I can't do it. Okay, it's because it is not that I when I'm adjusting that to 11,000, it can't make 11,000 out of something that's less than 11,000. It could only slide in. So if I repeated that, select this edge, keep existing, we'll say yes, and let's go by selected. And this time we'll say 7,500. So see, it pulled that line over here. It's parallel. So now it would take this interior side to be 7,500. And then that one would be the lesser amount. So if I need to make it, if I want 11,000 to where it's within this, I need to make this one slightly bigger than 11,000. So I'm going to go to this offset command. And this is going to be a variable offset. I'm going to select by lines. And I'm going to select this polyline and which side to offset, this side. So this one's going to have an offset of 0. That's an offset of 0, offset of 0. And that one I'm going to say 50 feet. All right, so now there's my original, or there's my new side. And I'm done. So I'm going to take this original and throw it away. And I'll do a sliding side or a hinged side on that one. Adjust, not hinged, but sliding side. By line work, select the segment to adjust this one. Keep existing. Yeah, let's see it. We'll say by selected, and we'll call 11,000. Now, that should be correct. Draws a closed polyline, sure. We'll draw the closed polyline. So now that one is not what I want. I want this one. Right there it is. So there's 14. So I need to bring that back in. So let me explode these. And I'll get rid of this, I think. No. Just get rid of this, and this. So now I've got 1, 2, 3, 4. True enough. Join, or actually, I'm just going to take this and I'm going to, let's move it, or let's copy it from this corner point back over here to this corner point. Boom. Oops. Well, that's going to make that, let me see, is that, let's join nearest. Is that 11,000? It's still way the wrong darn line. Sorry. Let's take this off, do this one more time. Adjust my area with a sliding side by line work. choose this segment, keep existing, sure. We're going to say by selected, target of 11,000. So now there's where the new line's going to go. Draw it as a closed polyline. I'm just going to say by line. So now I've got this single line drawn. I'm going to match my properties there. So I'm going to match that to be that. Now if I take this to this is my 11,000. All right, let's do sliding side by line work. Let's adjust that edge. Keep existing, yes. By selected, 11,000. That's really more what I wanted. But now that's parallel to this. All right, so let's put a sliding side at line work. We're going to adjust that edge. Keep existing, sure. And we're going to choose this line as my parallel line. That's what I wanted there. So now I'm going to take, I just say, just draw the line. I'll now match those. I don't have to match these. I'm just bringing it up. And I'm going to now take this and let's copy that from this bottom corner over to this corner. Now that should give me 11,000 here, and then whatever that left over is from this total of 22, whatever it is. So I need to adjust this line to that line. So I'll do that by moving these points. I'm going to move the lot edge point. We'll move this point up to here. And I'm going to move this point down to here. Let it recompute. So there's now my 11,000 square foot there. I've got 12,000 square foot there. Now it also may have, another reason it was forcing that other line orientation was it had to satisfy these setbacks and stuff. So it may have violated a rule in there. But right now, there's my line work. Got my driveways. I've got some adjustments. You could do the same thing down here, adjust this line and do your tweaks about that. And then you've got your entire subdivision done. And again, you could, if you, when you're setting these as part of your rules, you can have it, come through here and create that you set the building pads up at their, at particular elevations. See, right now there's no elevations. I don't have an existing terrain defined underneath it, but if I did, we could use that to set some grading rules. If I had the civil module, this would then elevate and grade all of these lines in, and we'd couple this road network with road profiles instead of just the center lines. And it can adjust all of that stuff automatically. So with the civil module, like I said, you can have lot network drive everything, including the grading on all of the lots. Okay, so right now, there's a subdivision. Here's where the developer might want to choose that lot for himself. It's a nice big fat lot on the back corner over here, or, anything along those lines. All right. So that puts us at pushing in toward our 5 o'clock, and we missed our after or earlier break. So we'll call it 5 o'clock, and everybody gets an extra half hour in your PDHs. So Heath, that's at least something for you.
Um, so when we issued these certificates and links to the videos, your certificates will reflect that additional half hour of professional development credit. So it's a half hour less. You'll have to sit in another lecture somewhere else. So, all right. Any questions to this point about LotNet or anything else that we may not have touched on? Anything that you'd like to see real quick? I'll be glad to stay if anybody wants. If not, we'll call it a week. Everybody good or any questions? Thank you, Miss Kimberly. You have a good weekend yourself. There's Scott Cochran. All right, nice to see. Kimberly, I don't know how you are set in terms of children, nieces, and nephews, but down here in Oakmont on Sunday, they're having a Touch the Truck sponsored by the Lions Club. I'm in the Lions Club, so um, it's a pretty nice event. Get the kids in, let them play around with some big trucks and heavy equipment, that sort of stuff. Or you may want to, sit back with a nice mimosa on the patio and forget about touching trucks. So, but just to let you know, in case you're not aware of it, they're doing that on Sunday. They do that every year, except COVID interrupted it. So, oh, great, come by. It's sponsored by the library and the Lions Club, and starts at 1 o'clock. So help yourself, feel free. And I'm actually in the Lions Club band as well. I think we're playing at some point through the afternoon. Will be set up. So, and it's just a little jazz band. I play trumpet in the band, but anyway, not trying to solicit any other engagement, but it might be something if you got some smaller kids in your life. They always seem to have a great time with it. There's fire trucks, there's ambulances, there's tree trimming trucks. One year we had a sewer line inspector and inspecting or sewer line inspection and cleaning truck. And we had the manholes popped on the main street there in the main drag through town. So it's all pretty neat. We were going to have some drill rigs in this year for geotechnical drill testing, but they wound up being scheduled out of town and couldn't make it. So anyway, that's that. I wish everyone a great weekend. I will stop our recording